Hi everyone, welcome to Java Techie. As I announced before, I am going to start Kafka series from beginner level to advanced level, and this is the part 1 video of Kafka series. And agenda of this tutorial to understand what is Kafka, where does Kafka come from, why do we need Kafka, how does it work with high level overview. Okay, so without any further delay, let's get started. So let's start with what is Kafka. If you open the official page of Kafka, you will find this definition. Apache Kafka is an open source distributed event streaming platform. What does it mean? So let's break down these words to understand in better way. When I say event streaming, it points to two different tasks. Create real-time stream, process the real-time stream. Let me explain these two words with an example. Okay, so I hope everyone uses Paytm in this digital world. If anyone does not know Paytm is a UPI payment method. Let's assume I am using that Paytm application to do some payment, or I am booking the flight ticket, or I am just booking some movie ticket. Okay, because Paytm provides us feature to do any type of transaction. Now when I will do any transaction, that event will go to the Kafka server. But I am not the only one Paytm user who is doing the transaction at this time. Since people uses this across globe, this Kafka server receives million or billions of event in each minute or each second or even in each millisecond, right? So sending the stream of continuous data from Paytm to the Kafka server is called creating real-time event stream or generating real-time stream of data. Now once Kafka server receives the data, he need to process it, right? So the Paytm team or Paytm developer created one client application which will read the data from the Kafka server and do some process. For example, let's say Paytm want to restrict max 10 transaction per day. I mean a user can only do 10 transaction per day using Paytm method. Okay, if it exceeds the limit, then client application wants to send a notification to the user. In such scenario, my client application needs to continuously fetch the data and need to do the validation to check the transaction count for a specific user in each and every seconds or millisecond, right? So this continuously listens to the Kafka messages and processes them is called processing real-time event stream. Okay, so if you combine these two terms, this will give you the answer what is event streaming. In simple words, continuously sending the message or event to the Kafka server and reading and process them is called real-time event streaming. Now let's move to the next word called distributed. In microservices world, distributed means distribute multiple computers to different node or region to balance the load and to avoid the downtime. Similarly, as we know, Kafka is a distributed event streaming platform. We can also distribute our Kafka server. If you can observe here, we have three Kafka server running in different region to perform event streaming operation. In case if any server goes down, another server will come up to pick up the traffic to avoid application downtime. Okay, hope you understand what Kafka is or why it is called a distributed event streaming platform. Now let's move to the next point, that is where does Kafka come from? Kafka was originally developed at LinkedIn and was subsequently open sourced in early 2011. Now this Kafka software comes under Apache Software Foundation. Okay. Now let's move to the next point. Why do we need Kafka? So let me walk you through an example to demonstrate this particular point. Let's say I have some parcel on my name. So postman come to my door to deliver the parcel. Unfortunately, I was not there in my home and went for vacation. So he returned back. Again next time he came, but I am not there in home. He tried 2-3 attempts to deliver the parcel, and every time I am not there in my home. After some day, he might forgot about the parcel or he returned the parcel to the main office. In this case, I lost the data, or I will not able to receive the information what postman bring to my door. That parcel could contain some important information or money related stuff, but I missed it because I was not available during the period when the postman came to my door. This could be a huge loss for me, isn't it? How can I overcome this? No worries, I am very smart. I have installed a letterbox near to my door. So when next time parcel postman brings for me, and if he found I am not there in home or I am not available in my home, then simply he can put that parcel to my letterbox. So whenever I will be back to my home, it can be a day after or a week after, I can go to my letterbox and I can collect the parcel or the messages what postman dropped in my letterbox. In that case, I will not lose the data. Data will be there in my letterbox until I pick it up. Here the letterbox acts as a middleman between the postman and me. How cool is this? Isn't it? Let's try to relate this understanding with one real-time example. Let's say I have two applications, application 1 and application 2. Now application 1 wants to send the data to application 2. But if application 2 is not available to receive the data, then again he will lose the data like me, which might impact to the business of application 2. So to overcome this communication failure, we might need to install something similar to the letterbox between these two applications, right? That is where Kafka comes into the picture. You can add a messaging system between application 1 and application 2, and that messaging system can be a Kafka, or it can be a RabbitMQ, or it can be a Redis. Okay, but we are going to focus on the Kafka messaging system. So in case application 2 is not available, he can collect the message from Kafka whenever he will come online. This Kafka again will act as a letterbox between application 1 and application 2. That is how he won't lose the data, right? Hope now you understand why we need Kafka or messaging system. Now let's understand the need of Kafka with more complex scenario. Okay, let's say you have four applications who wants to produce different types of data to the database server. This looks simple. What is the problem here? Nothing as of now. But in future, your application can grow. You might have n number of services to communicate with each other. In that situation, it's really tough to manage these many connections between the services. There could be a lot of challenges. What could be the possible challenges? Data format, connection type, or number of connection. When I say data format, this front-end app maybe want to produce some different type of data to each different type of application. Maybe front-end want to send some payload structure to database server and some different payload structure to security system. Similarly, Hadoop also might to do or might to send some different type of data. There could be a complexity to handle the data format or schema. And next, connection type. So there could be different type of connection. I mean, when I say different type of connection, it could be a HTTP connection, or it could be a TCP connection, or it could be a JDBC connection. Like the connection type will be complex to maintain with multiple services. Okay. And second is number of connection. When I say number of connection, if you observe carefully, front end connect to the 5 different destination services. Hadoop connected to different 5. Database slave connected to 5. and chat server also connected to 5 different services. So if you count the number of connection here, the total count will be 20. So to just maintain, left side is 4 application and right side is 5 application. So just to maintain 9 application, or to just communicate between the 9 application, we need to manage the 20 connection. In enterprise application, really it's kind of a bottleneck situation to handle above challenges. Then how to overcome it? That is where this messaging system like Kafka came into picture. So if you observe this particular diagram carefully, now front-end Hadoop database slab chat server, whatever the data type they want to send, or whatever the schema structure they want to send, or which type of connection they want to make, they'll simply send the payload or information to this particular Kafka server or my messaging system. Now, which kind of data this data server need? He will go to the Kafka server and he will directly get it from this Kafka server. Similarly, let's say security systems want to fetch some data given by either Hadoop or database slave. He can simply go there and check the data, what he was looking for is there or not. If it is there, he can simply get those data and he can play with those data. In this approach, we are maintaining a centralized or similar to the letterbox. All the front-end Hadoop database slab chat server, they will drop the messages, and other 5 downstream services will go to those Kafka server and they will pick the messages as per their need. And in this approach, we are also reducing the connection count. Can you observe here the total number of connection here? 1, 2, 3, 4. 1, 2, 3, 4, 5. Total 9 connection. In previous approach, we found 20 connection, but when we centralized using the Kafka, we are reducing the connection count as well. Okay, so this is the advantages of using the messaging system like Kafka. I hope you understand why do we need Kafka server or Kafka as a messaging system. Now let's move to the next point, that is how does it work. I will just give high level overview to understand how this Kafka or messaging system works in real time. Okay, so this specifically works on PubSub model. When I say PubSub, Pub stands for publisher, Sub stands for subscriber model. Okay, so usually there should be 3 component: publisher, subscriber, messaging system, or you can say message broker. Okay, publisher is the person who will publish the event or messages to the messaging system like Kafka. Okay, and the message will go and sit in the message broker. Now the subscriber will go to that particular message broker and will ask for the messages, or subscriber will simply listen to that message broker to get the messages. Okay, so this is just 50,000 high level overview of the PubSub model. Don't worry, we'll understand in details how the message is getting processed inside the broker and what all components helps to process the message in my coming session. Okay, so this is just a heads up tutorial to just get basic information about Kafka and its need in real time. This is part 2 video of our Kafka series. In this tutorial, we are going to discuss about Kafka architecture and its components. Okay, alright. If you understand the Kafka terminology and its purpose, then you can picturize internally how a message is going to flow from producer to the consumer via broker or Kafka server. Okay, so without any further delay, let's get started. So these are the Kafka components, or you can say core concept of Kafka. Here each component play a different role in the Kafka ecosystem. No worries, we'll discuss one by one. Okay, so let's begin with the first one, that is producer. If you understand the PubSub model in our previous video, the producer is the source of data who will publish the messages or events. The consumer acts as a receiver. It is responsible for receiving or consuming a messages, but they won't directly communicate with each other. To process the messages from producer to the consumer, there should be one middleman between them. That is what called Kafka server or broker. In PubSub model, usually producer will publish or push the messages to the broker, then broker will store that messages, and then consumer will consume it from the broker. In other words, you can say a broker is just an intermediate entity that helps in message exchange between a producer and a consumer. Okay, so this is what the basic key component of your PubSub model and producer, consumer and broker. Let's move to the next one, that is cluster. So I believe everyone heard the word called cluster. If not, a cluster is a common terminology in the distributed computing system. It is nothing but just a group of computers or servers that are working for a common purpose. Since Kafka is also a distributed system, it can have a multiple Kafka server or brokers inside a single Kafka cluster. So there can be one or more Kafka brokers inside a single Kafka cluster. Let's assume your producer is publishing huge volume of data. Then a single Kafka broker may not able to handle the load, right? So you might need to add additional Kafka server or additional broker. So you can group multiple broker using a Kafka cluster. Fine. So next, let's deep dive inside the brokers to understand what all core components it has to store the messages. Okay. So let's move to the next component, that is topic. So before I explain the theory, what is the topic, let's find out why it is there inside a broker. Let me walk you through the same PayTM example. As you understand, the PayTM application will keep sending different type of activity to the Kafka server, and the PayTM client app will continuously listen the messages from the Kafka server, right? So here the left part is my producer and the right side is my consumer, and the middleman is the broker, or you can say Kafka server. So broker receives different type of messages or events here. It can be a payment transaction, or it can be a ticket booking, or it can be a specific to the mobile recharge related message, right? Now consumer needs to read all the messages to process them. So the consumer asks to the broker, hey, give me all the messages you have received. Then the broker checks his storage and replies to the consumer, hey consumer, I have a lot of messages with me. Which one you need? Again consumer asks, hey broker, give me all payment specific messages. Again broker attack with the counter question, hey buddy, I have different type of payment messages with me. Which one you need? Now it's gone, right? The consumer hurts by broker counter question. This is obvious, right? Then how we can overcome this back and forth conversation? That is where topic came into picture to categorize different type of messages. So how topic can help here? You can simply create multiple topic to store different type of messages. Even you can rename the topic payment topic, booking topic and insurance topic. If producer sending payment specific messages, then the message will push to this particular payment topic. If the message type or producer is sending booking related messages, you can keep those messages inside this booking topic. Or similarly, if producer is sending some mobile recharge specific information, you can keep it separate topic. This is how you can segregate different event type to different topic. So here consumers have no need to have a back and forth communication with brokers. Whatever messages consumer want, he will simply needs to subscribe that specific topic. For example, I have a consumer who needs only the booking specific messages. Then I'll tell him, hey consumer, you go and check directly in the booking topic. You no need to ask to the broker to give me booking specific messages. You simply go to the booking topic, or you simply subscribe to the booking topic and get all the messages what you need. This is very simple, right? Alternatively, you can consider the topic act as a database table in Kafka ecosystem. So usually we store employee information in the employee table and payment information in the payment table in database world, right? Similarly, when producer send employee specific event or messages, we need to store them in the employee topic. And similarly, if producer is publishing payment specific information, then we need to store it into the payment topic, right? Now, if you have multiple consumer, then they can go to a specific topic and consume the messages as per their need. For example, if consumer 1 wants to read all employee messages, he can go and collect the messages from the employee topic directly. He no need to ask to the broker, hey broker, give me the employee specific messages. He know that employee topic contains all the employee specific messages. Consumer 1 can come to the employee topic and can get the info. Similarly, all the consumers can subscribe to the corresponding topic what information they want to listen. Okay, so if you look into its actual definition, topic specifies the category of the messages or the classification of the messages. Listeners can then just respond to the message that belongs to the topic they are listening on. So consumer 1 want the payment info, he can go and listen to the payment topic. That is what the need of topic, or this topic play a critical role in Kafka ecosystem. Okay, so let's move to the next key component, that is partition. Now we know that Paytm producer sends data to the broker and the broker store the message inside a topic. Now consider you have a huge volume of data. When I say huge volume of data, let's assume your producer is publishing millions or billions of messages per second to the topic. Then will my topic be able to handle those many messages? Obviously no. There could be a storage challenges, or it can be very challenging for the topic to store data on a single machine, right? Then how to handle this situation? Solution is very simple. As we already know, Kafka is a distributed system. In such a scenario, we can break the Kafka topic into multiple parts and distribute those parts into different machines. This concept is called topic partitioning, and each part is called partition in Kafka terminology. Okay, so this partitioning will give you better performance and high availability, because if you observe, we split our topic to multiple partitions. So when producer publish bulk messages, then each partition concurrently accept the messages. That will definitely improve the performance, right? Even in case if any partition goes off, then other partitions are available to handle the loads without any application downtime. This is the reason topic partitioning is the key aspect in the Kafka ecosystem, and we can decide the number of partitions for a topic during Kafka topic creation. Okay, no worries, we'll hands on with these terms in our coming videos. So now let's move to the next component, that is offset. So far we understand a Kafka cluster can have one or more Kafka server. Then a Kafka server can have multiple topics, and each topic can have multiple partitions, right? Now when producer send a message, then it will go and sit in any partition inside a topic that we don't have any control on it. It will work based on the round robin principle. So if you observe, as soon as message arrives in a partition, a number is assigned to that message. That is called offset. 0, 1, 2, 3, 4, 5. These are the sequence number assigned to each and every messages. That is called offset. So the purpose of offset is to keep a track of which message have already been consumed by the consumer. For example, let's consider after reading 4 messages from the partition, consumer went down. Okay, then when consumer will back to the online, then this offset value would help him to know exactly from where the consumer has to start consuming the messages. Now here if you observe, consumers should start reading message from offset 4, not from the 0 again, right? This is what the key role of offset. Fine. Now let's move to the next component, that is consumer group. So I believe we all are clear up to this. producer will push huge volume of messages to the Kafka topic, and message will again split to different partitions, and inside partition each message have their own identity with offset number. So now let's go one step ahead. Who will listen to the messages from the partitions? The single statement is consumer, right? But if you observe here, I have three partitions and a single consumer is reading from each and every partition, which will definitely leads the performance issue because there is no concurrency. You can see here a single consumer is playing with all the three partitions. So definitely it won't give us the better throughput, right? Then how we can overcome this situation? It's very simple. Just share the workload. How can I share the workload? So what I will do simply, I will define n number of consumer instance. Now I can group all the three consumer what I define into a single unit by specifying the group name that is called consumer group. Now payment consumer group have the three consumer instance. Now since I have multiple consumer with me, I can divide the workload to each and every consumer to achieve better throughput. So simply now my consumer 1 can read from partition 0, consumer 2 can read all the messages from partition 1, and consumer 3 can read from the partition 2. Then in this approach, all the three consumer instance read parallelly from each and every partition, which will definitely give me the better performance, or we can get the better response, right? Just keep a note, we can't guarantee about consumer and partition order. Any consumer can talk to any partition, that will be decided by the coordinator. Okay, so you can say consumer 1 might listen from partition 2 or any order. Okay, we don't have any control on it. Cool. Now you might have a question, hey, I have three partition, so three consumer, so they will talk to each other. That's correct. But what if I have a fourth consumer added to my consumer group? Then what will be the behavior of this consumer 4? What he will do? Right? There is no change. That consumer 4 will sit idle because there is no work for him now, since all the three partitions assigned to three different consumer instance, there is no partition left for him, so he will simply sit idle. But in case if any consumer instance is rejected or goes off, then C4 will get a chance to connect with any partition. This concept is called consumer rebalancing. Don't worry, I will cover this part in the coming session. Okay, fine. Now let's move to the next component, that is zookeeper. So zookeeper is a key component for Kafka. Kafka is a distributed system and it uses zookeeper for coordination and to track the status of your Kafka cluster. Okay, it also keeps the track of Kafka topics, partitions, offset, and all the component of the Kafka ecosystem. So in single word you can say this particular zookeeper will act as a manager for your broker or for your Kafka cluster. Okay, so this is what all the key component of Kafka. We have seen the concept of Kafka architecture. Moreover, we discussed Kafka components and basic concept. So furthermore, for any query regarding architecture of Kafka, please feel free to ask in the comment section. We'll discuss more internal of each components in our coming session. Okay. So before we install Kafka, let me tell you that we have different kind of Kafka server available in market with different type of flavor, like Apache Kafka, which is open source, commercial distribution, managed Kafka service. So let me give you some heads up about above three Kafka flavor so that you can able to understand which Kafka service need to choose based on the situation or based on the scenario. Okay. So the first one is open source version of Apache Kafka. This you can easily download from Apache portal and then you can install and use it. In case if you face any operational issue or open bug on Kafka, then you need to manage it by your own, or you might need to upgrade if needed. So maximum company still use this open source with proper infrastructure setup, and also they have dedicated developers or experts to handle any kind of infra related issue. So the second one is the commercial distribution that comes with a lot of tools and utility to perform your day-to-day Kafka operation. This will add cost to your organization or to the project, and Confluent Kafka is one of the best commercial distribution to use, which simplifies connecting data source to the Kafka, building streaming application, as well as securing, monitoring, and managing your Kafka infra. So today, if you will observe, Confluent platform is used for a wide array of use case across numerous industries. And Confluent Kafka also provide a community edition for developers which is completely free. Don't worry, I will show you how to use the community edition of Confluent Kafka. Next is managed Kafka service. This comes with everything you need. You just create instance as per required configuration. Let everything managed by the Kafka provider. All infrastructure will be ready for you, and it really easy to scale when needed as similar as cloud infra. So Amazon MSK and Confluent are best managed Kafka service provider to use. So based on the project requirement and budget availability, you need to decide which Kafka service need to choose. Okay. But as part of this course, we'll use the open source Apache Kafka. But don't worry, I will also demonstrate how to use the community edition of Kafka Confluent. Okay. So let's begin with the installation steps. So I'll walk you through the steps to install Apache Kafka, which is open source. Also, we'll install the community edition of Confluent Kafka. Then at the end, we'll install Kafka Offset Explorer, which will help us to monitor our Kafka messaging system. Okay, so let's begin with the first one, that is installation of Apache Kafka. So we are going to download the open source of Apache Kafka. So for that, go to the Chrome browser, and then you can search here Kafka. Go to the official page of Apache Kafka. Then you can find the option to the download. Click on download Kafka. So the latest version you can find your 3.4.0. Okay, so you can download any of them. This is the binary distribution. So let me click on the first one. The file size is 102 MB, so it will take few seconds to download. So once the download will be completed, go to that particular folder. So you need to extract this particular folder. You can see here the version we downloaded 3.4.0. Now go inside this particular folder. You can find bin, config, libs, license, and side docs. Okay, so inside the bin you will find all the shell script file for Mac and all the batch file for Windows. So if I will open this, you can see here all the .sh extension is being used for the Linux or Mac operating system, and in the Windows you can find the .batch file to start the zookeeper or to start the Kafka server or to start the topic or to create the topic. All the things whatever we have discussed before, you can play by executing this batch file or by executing the shell script file. So once you will download the binary distribution, you will find the support for both operating system. This is for Windows and this shell script is for Mac or Linux. Okay, and if you go inside the config, it contains the properties file. Okay, so you can see here server.properties, which holds the Kafka properties specification, and you can see here zookeeper.properties. Okay, so these are the properties file. You will understand once you will play with those properties file. Now if you will go here inside the leaves, there are a couple of jar. That's it. Okay, you just need to download this binary distribution, then all set. In upcoming session, I will show you how you can play with the Kafka component by executing this script. Okay, so let's move to the next one, that community edition of Confluent Kafka. Okay, so to install the Confluent Kafka, what you can do, you can go to the confluent.io, then you can click on get started free, and you want to install the software which is community edition of Confluent Kafka. We don't want any managed Kafka service, So navigate the tab to the softwares. Next, you can fill this form and then just acknowledge these two. Click on start free. Here we go. So if you observe here, there is a local install Confluent platform on a single local machine by using zip or tar archive or docker images. So we don't need this. What we need? We need the community edition. Okay, there is something called distributed Confluent for Kubernetes, and there are few more. So we need to focus on this community, which is completely free. So you can see here, use it for free forever. Okay, so we want to install the zip, or we just want to download the zip. Just click on this download. This is the size 466 MB. Okay, so let's wait it to complete. So once it downloaded, just show in the folder, and again you need to extract this. You can see this, right? The latest version of community edition of Confluent Kafka is 7.3.2. Fine. Now go inside this particular folder. You can find the same structure, that is bin, and you can find the file, which is the shell script for Mac and Linux, and for Windows you can file this batch file. Okay, and if you will move further inside this etc, as I already mentioned, once you are playing with the Confluent Kafka, apart from Kafka you will find lot of utility. When I say utility, you will find Kafka REST, KSQLDB, REST utils, Schema Registry. So we will understand about this particular utility in our upcoming session. Okay. Now if you will go inside the Kafka, you will find the properties file. Okay. So whatever files you downloaded through the Apache Kafka open source and Confluent, each file is similar, only the structure is changed. So let me compare this so that it will be easy for you to understand. Okay, let me open the Kafka, and meanwhile I will open the another window for Confluent Kafka. Okay, now let me. So this is the Kafka and this is the Confluent Kafka folder. Now if you will compare these two folders, if you will go inside bin, you will find the script file and Windows file, and again if you will go inside this, you will find the same. Okay, now if you will go back and if you will check about the config, you will find all the properties file, but in Confluent Kafka, since it supports for multiple utility methods, inside the etc you will find a folder called Kafka. Inside that Kafka you can find the properties. Okay, and these are the utility. Fine. This is the only structure changed you will find between these two, Kafka and Confluent Kafka. Okay. So as I mentioned, I will just show you how you can play with both. Okay. That is my next session. I will just demonstrate using the command line interface how we can play with all the Kafka component in open source Apache Kafka and in Confluent Kafka. Fine. Now the next we need to install the Kafka Offset Explorer to monitor our Kafka messaging system. So what you can do for that, go to the Chrome and just search here Kafka Offset Explorer. The first link you can find something called Kafka tool. Okay, so just open this link and then let me zoom this for you. You can see here, right? Offset Explorer. This is the Kafka tool, is a GUI application for managing and using Apache Kafka cluster. Okay, so just click on the download. You will find the option to download for Windows and Mac. So download based on your operating system. So since I am using the Mac, I'll download this particular Mac OS. So the size will be 60.2 MB. So once it will be download, you just need to double click to install it. Okay, so let's wait it to complete. So it downloaded, just show in the folder, and you just need to double click on it. Okay, so that it will be installed to your machine. drag and drop. I have already installed it, so it is asking me whether you want to replace or you want to keep the both. So I will just stop for now, okay, because already I installed it. So I will also remove for now. Fine. So this is what about the installation steps. In my coming tutorial, I will show you how you can play with the Kafka component using the command line interface. We'll create the consumer and producer. We'll publish the event to the topic and we'll add the partition and we'll show the various type of behavior in this particular producer and consumer flow. Okay. So we already downloaded Kafka binary distribution, right? Now what next? First we need to create or start a Kafka ecosystem. For that we need to start a Kafka server or broker, okay? But to manage this Kafka server we need a manager which is Zookeeper. So the steps we need to follow: start the Zookeeper, then next we need to start the Kafka server or broker. Once you have the Kafka ecosystem ready with you, then we can start producer and consumer. Since we are playing with command line interface, we'll use the command to create producer and consumer for now. But in my upcoming session, I will create two different applications for producer and consumer. Okay, cool. Next, producer wants to send a message to the consumer, but they can't directly communicate with each other. So we need another component called topic, so that producer can push the message to the topic and consumer can consume it. Okay, once you have created the topic, next you can define n number of partitions to distribute the load coming from producer. For example, let's say my producer wants to send 10 messages, then those messages will distribute to all three partitions, assigning with offset number. So while creating a topic, you need to specify the partition count. You need to take the decision based on the load coming to your application, how many partition will be perfect fit for your topic. Okay, that decision you need to take while creating the topic. Once a message reaches to the partition, then immediately whoever consumer listen to it, they can happily consume it. So this is the typical producer and consumer flow. We'll follow the same steps to deep dive further. Okay, so using the command line interface, we'll start the Zookeeper Kafka server, we'll create the topic, then I will show you how you can define the partition. Then also we'll understand how the bulk message is being distributed to the multiple partition and how it is being consumed by the consumer. Okay, so to play with the command line interface, you need to go to the folder where you install the Kafka. So it is there in my download folder. I have created a folder called softwares. Inside this I have kept these two Kafka. Okay, so I'll show you how we can do using Kafka. Also I will demonstrate how we can do using the Confluent Kafka. Okay, cool. So first step, what we understand? First we need to start the Zookeeper, right? Then you need to start the Kafka server. So what you can do, go to the folder, then go to the Kafka, open a new terminal. Fine. Then I will also create couple of terminal. Just go here, new terminal. Fine. Let's go with these three. Let me minimize this. Okay. Fine. So first I need to start the Zookeeper. So how can I start the Zookeeper? You need to fire the command. So there is a shell script file you will find inside the Kafka bin directory. So if you'll go inside Kafka, if you go inside bin, you can find here something called Zookeeper server-start.sh. Okay. So what we can do, we'll run this particular command. So this is inside bin folder, Zookeeper start server start.sh. Okay. Now to start the Zookeeper, it needs to read the zookeeper.properties file. So again, if you'll go inside the config, you'll find a property called zookeeper.properties. Can you see here? This properties, it needs to start the Zookeeper server. So you just need to simply give the path of it. It is inside config. Let me zoom this for you. it is inside config and the file name is zookeeper.properties file. Now just enter it. It will take few seconds to start the zookeeper, and the default port it will run 2181. Okay, so I can show you that. Let me filter it 2181. Can you see here the default port is 2181. Now as per the presentation we understand, after start the zookeeper we need to start the Kafka server. So go to another terminal. Let me use the second one. Here you need to start the Kafka server. How can we start the Kafka server? Again, if you will go and check in your bin folder, you can find something called Kafka server start.sh. This is the shell script file. If you are using Windows, you can go inside the Windows and you can search for Kafka. Where is the Kafka server? Yeah, this one. You can run this Kafka-server start.batch file. Okay. Since I'm in the Windows, sorry, I'm in the Mac, I'm using the sh file. So just go to the terminal and just run. It is inside bin. Okay. Kafka-server start.sh, and to start the Kafka server it needs to read the properties file called server.properties. So if you'll go inside the properties file or config folder, you will find something called server.properties. Okay, so you need to give this properties file to start the Kafka server. So again give the path config slash server.properties, just enter it. Yeah, it take few seconds to start your Kafka server. Now to check which port this Kafka server is running, you can filter something 9092. Can you see here? This is the default port of Kafka server. So just keep a note. The default port of zookeeper is 2181 and Kafka server or broker is 9092. Okay, so that's it. Now our Kafka ecosystem is ready. Now what is the next step? If you understand correctly, then the next step, producer and consumer need to communicate with each other using the topic. So you need to create a topic and you need to specify the partition and replication factor. Okay, so to run a topic, again I will take the help from this command line interface. Okay, now if you go inside the bin folder, you will find something Kafka-topic.sh. Okay, so what I can do, I'll just run here. I need to go inside bin, then Kafka-topic.sh. Also, I need to tell here while creating the topic, I need to give my bootstrap server host and port. When I say bootstrap server, it's about your Kafka server. Okay, now I'll define bootstrap strap dot server. My bootstrap server is running on host localhost and port is 9092. This is where my Kafka server is up and running, right? So let me make this wide so that we can type in a single line. Okay, I have ran the Kafka-topic.sh and I am giving where is my Kafka server is up and running. The host is localhost and port is 9092. Now what action you want to do? I want to create a topic. Okay, and what is the topic name you want to give? Let's say I want to give JT topic, or let's give a valid name Java Techie underscore or hyphen topic. Okay, now how many partition you want to define? So if you won't define anything, it will take the default partition as a 1, but you have option to define n number of partition. So as of now I just want to define 3 partition. Okay, partition count equal to 3. Now how many copy you want to keep? That is called replication factor, right? Since we are running on a single broker, so let's keep the replication factor as 1. So you can define replication factor equal to 1. So there is nothing complex to remember this command or this particular command whatever we have typed here. I am just running my topic by giving the information where is my Kafka server is up and running by defining the host and port and what action you want to perform. I want to create a topic and the name of the topic is java-topic and the number of partition I want to assign as 3 to this particular topic and I want to keep a single clone of this particular broker. So that is the reason I have defined replication factor as 1. Now click on enter. So the mistake we have done, we no need to add the dot, it need to be hyphen. Okay, so let me zoom this for you. Now let me drag this. Yeah, now let me enter it. Can you see here? It created the topic Java Techie topic. You can define n number of topic if you want. So let me create another topic, topic 1. Okay. Now we have created 2 topic. So to list down all the topic available inside your Kafka server, what you can do, you can simply run bin, same command kafka topic.sh. In this particular server, just give me the list of topic. Okay, so I can happily copy this command. Then you can run it here and just ask him to give me the list of topic. Now if you will enter, we will find the 2 topic, Java Techie topic 1. Now if you want to describe this topic to know what is the number of partition, replication factor, who is the leader. So if you want to describe this topic, that is also straightforward. You can run a command. So what you can do, run the same command and ask him to describe the topic name. So I just want to describe Java Techie topic. Okay, this is what the topic name we have, right? I just want to describe this. Run it. What is the error? Okay, I need to define that I want to describe a topic, right? So describe, then you can tell him what you want to describe. I want to describe topic. There is something wrong. I might be doing some spelling mistake. Let's see. Kafka-topic.sh bootstrap server 9092. Okay, I don't want this list because I want to describe. So this is the mistake. You need to understand this particular command. Okay, you just no need to remember it. Just understand what you want to perform. Okay, now just enter it. Can you see here? Okay, let me take the background as different. Fine. Now if you observe here, the topic name is this and the number of partition we have defined 3, 0, 1 and 2. Okay, and replica is 0. So you can see here partition count equal to 3, replication factor equal to 1. There is no additional config given, so this is empty. Okay, you can describe the topic if you want. And also we have defined the number of partition. So we are done up to the creation of topic and defining the partition. Now we want to play with the producer and consumer. So since we are playing with the command line interface, I will run the consumer and producer application using the command line interface or using the command. Okay, so we'll run the producer, we'll push some message to the topic and we'll see whether it is being consumed by the consumer or not. Next step, we'll push bulk number of messages from the producer to the topic and we'll see whether the bulk messages is being getting distributed to the different partition or not. How we can monitor those things? We have installed the offset explorer, right? So what I can do, I will open the offset explorer. So what you can do here, very simple step. You just need to create a connection. And to create a connection, you just need to give a name of your cluster and where is your zookeeper is up and running and port of your zookeeper. So to not confuse you, what I will do, I will create a new connection. Let's say JT. I'll give the cluster name JT-con. Okay, localhost 2181. Everything it will take by default. Okay, so I'll give Java Techie -new. That's it. Click on test. Yes. Now if I'll open this, I have the connection to the cluster so that I can monitor everything going on this specific cluster. Okay. Now if I'll expand this, how many topic we can see here? Java Techie topic and Java Techie topic 1. So this is the two topic we created and we can able to see inside this particular zookeeper. Okay. Now if you will go and click on the data and if you will hit this particular thing, there is no data is getting filtered. If we will check the topic 1, there is no data, right? We want to push the data and we want to verify whether it is going to the topic or not. If it is going to the topic, then we will verify whether it is being consumed by a consumer or not. Okay, so what we can do quickly, we just need to start a producer and then we just need to start a consumer. Fine. So what we can do to start a producer, you will find something called Kafka console producer.sh given by the Kafka binary. Go inside the bin and if you will search here, can you see here? There is something called Kafka console producer.sh to just kicked up a producer application and Kafka console consumer.sh to run this command to behave as a consumer. Okay, so we'll run these two command. Okay, so what you can do, go to the terminal, this guy. Now I'll clear everything. What I want to do here, I want to okay, I'll minimize these two. Okay, we started the zookeeper and we started the Kafka server. Let's minimize it. Now to make it clear, I'm just running the producer application here. So you just need to run, go inside bin, Kafka console, right? Console hyphen producer dot sh, and then you need to give all the list of Kafka server available. Okay, so you can define broker hyphen list. Currently we have a single broker which is running on localhost 9092, but in real time you can find n number of brokers, right? So that is the reason you need to define them inside this list. Now to which topic you want to push your messages from producer, you need to define that topic name. So our topic name is Java Techie hyphen topic. Okay, that's it. Just enter it. Now it is asking you to push some messages. So we can push the messages and we can verify in the Kafka Offset Explorer. But meanwhile, let me start the consumer application so that parallelly we can push the messages from here. It will go to the topic, then consumer will consume from it. So I want to demonstrate the complete PubSub flow. So what I'll do, I'll open a new terminal to start a consumer. So go here and I just want to open a new terminal. To start a consumer, what you can do, go inside bin, then simply, let me zoom this for you. Go inside bin, then run Kafka console consumer.sh. Okay, now where is your bootstrap, to whom you want to listen? You can define bootstrap hyphen server which is running on port localhost 9092, and to which topic you want to listen. I want to listen from the topic Java Techie hyphen topic. Whether you want to listen from the beginning, if yes, just define I want to listen from beginning. Okay, don't do any spelling mistake while typing the command, otherwise it will give you the error. Fine. Now let's run this consumer. There is no messages being showing here. So what I'll do to make it simple, let me split into the two terminal so that we can see whether what we are sending we are able to receive it from the consumer or not. So let me split these two tab. Cool. Now the left side is my producer and the right side is my consumer, and they both can connected using this particular topic, Java Techie hyphen topic. Okay, producer is publishing to this topic and my consumer also listening to this particular topic. If you'll do the spelling mistake in the syntax or in the command, it won't work. So let's see whether we are correct or not. Let me send some messages. Hi, can you see here? We're able to see the messages in right side. Let me zoom this for you. Let me send something hello. We can see here. Let me send something Java Techie. We can see here. Let's send welcome. Let me some random number. Okay. So this is my producer application. From producer I am sending the messages. Okay. And this is the right part is my consumer. Let me minimize. Right part is my consumer. He is able to consume it. Now whether this message is being passed through the topic or not, how we can verify? Go to the offset explorer. Now just refresh your topic. Okay, we have these two topic, Java Techie topic and topic 1, but we are dealing with this Java Techie topic and there is a consumer offset. Okay, I mean it will just assign the offset and it will just set up to what your consumer read. Okay, now what I want to show you, I want to show you the data in this topic, Java Techie topic. Just run it. Can you see here how many messages we have sent? 5 messages. So the offset count being getting increased by 1, 0, 1, 2, 3, 4, and all the messages what we have been sent to this particular topic. Now from this topic, consumer is able to listen the messages and we can able to see here, right? Now if you will deep dive one step ahead, this particular topic we have created the partitions. How many partitions we have created? 3, 0, 1 and 2. Now if you check the messages in the topic, let me show you the messages inside the topic. I'll go to the data. All the messages went to partition 0, but still we have two more partition, partition 1 and partition 2. But why all the messages is going to partition 0? That is not in our hand. That will be taken care by zookeeper and coordinator. Okay, now we are playing with the very less messages, so all the messages is going to a single partition. Now let's say I want to push 1000 of row in single shot from the producer, then maybe the 1000 row could be distributed to different partition. Okay, this what we understand from the theoretically. Now let's prove it. What I will do, I will send a bulk file CSV data through the Kafka and we'll see whether the data is being passed to the different partition or not. So for that what I can do, I will cancel the producer. Okay, let it be. My consumer is keep listening. I'm not sending anything from the producer. That is fine. You won't find anything. But once I will start publishing the message, will keep my consumer will keep listening to it. So what I want to do, I want to publish a bulk messages. So what I have done, in my download section, I have downloaded a user.csv file. If I'll open this, it's loading. If you'll observe here, the total number of row present inside this CSV file is 1000. Okay, this is 999 and this is 1000. Including the header, it is 1001. Okay, So I want to push this particular messages from the Kafka producer. I want to push this user.csv file. How we can do that? That is very simple. So you can simply define the path of your file. It is there in my download folder. So I just need a path of my download folder. So what I can do, I'll just take the path of it, pwd, close it. I want to send the entire users.csv file from my producer. Just enter it. Can you see here? If I'll zoom my consumer, we can see all the 1000 messages in my consumer section. It means the CSV file, the bulk CSV file is being loaded to my topic. Can you see here? All the messages including the header, we can able to see the total number of row. Total number of row is 1001. So let's verify it in our offset explorer. Now we are seeing only the 5 messages. I didn't refresh it. Let me refresh it. Can you see here? There are so many messages. See, these are the CSV data. ID, first name, last name, email, and this is the IP address. That is what we have there in our CSV file. Okay. Now, all messages went to single partition or different partition. Let's verify it. Partition 0, the data. Okay. Now let's go to the partition 1. It didn't receive any data. The count is 0. Partition 2 also didn't receive anything. Okay. So all the messages went to the partition 0, but that is not always the same behavior. What we can verify? I will send it again, or I have another file called customers.csv. Okay, it is not there. Let me send the same users.csv. Fine. All the messages again being sent here. How we can verify? Let me go to the topic. Fine. Now if you will see in the partition 0, the total number of record received by partition 0 is 1546. So first we published 5 messages, then we published 1000 messages, then again we publish next 1000 messages. So partition 0 all total received 1546 messages. Now if you open the partition 1, it receives 46 messages. Okay. Partition 2 didn't receive anything. So whoever partition will get the messages is not in our hand. This will be handled by the zookeeper or coordinator. Okay. Now partition 0 and partition 1 have the messages. So don't worry, we'll demonstrate this behavior from our application once we'll create the producer app and consumer app. This is what we are just trying to understand the behavior of partition and distributing the messages to multiple partition through the command line interface. Okay. So I believe we are very clear about the producer consumer workflow, and we have discussed everything what we have covered in this particular slide. We have started the zookeeper, we created the Kafka server, we create the topic, define the partition, and also we understand how the load is getting distributed to the partition, how the offset is being assigned, how the message is being published from producer to the topic, from the topic to the consumer. The entire workflow we have covered just now. Okay. The next, whatever we have discussed, everything on open source Apache Kafka. Now the next, I will walk you through a small steps how you can play with the Confluent Kafka. Okay. So which is the community edition we have installed or we have downloaded yesterday, right? So if you will go to the desktop, if you will go to the downloads software, we have this Confluent, right? Confluent Kafka. Now to start this Confluent Kafka, you need to stop the open source Apache Kafka, because the zookeeper server and Kafka server both are using the same port. The configuration is same, right? So you need to stop them first. What I'll do, I'll stop everything. Control C, I stop my producer, I stop my consumer, which I ran in open source Apache Kafka. Then I need to stop this Kafka server. Then I need to stop my zookeeper. Where it is. This guy. Yeah, just stop it. Fine. So I'll clear everything. Anyway, I need to close this particular terminal because we want to play with the Confluent Kafka now. So what you can do, go inside this folder, just open a new terminal at folder. Everything is same. Each and every command is same. Only you need to give the different path of your config. Okay. So what I mean, I'll show you. We'll follow the same. First we'll start the zookeeper, then we'll start the Kafka server, then we'll create the topic by defining the partition, then we'll see the messages. So for that, what I can do, I will just go to the folder and I will open a terminal, new terminal. Let me open a couple of terminal. Okay, fine. I have created 4 terminal. Now first let me start the bootstrap server. Sorry, zookeeper, right? So to start the zookeeper, I will run the same command. See here, this is what we have ran in. Let me zoom this for you. The same command we have ran for open source Apache Kafka. Only thing you need to define, instead of this config, you need to give the actual path of your zookeeper.properties file. So if you check here, the zookeeper.properties file is inside etc Kafka and then the property file, right? So you need to give that path. Instead of config, just change it to the, it is inside etc hyphen Kafka and zookeeper.properties. Just run it. Okay. So I'm already there inside bin. No, right? Okay. So what I'll do, I'll clear it. Let me copy the command. Okay. I've already documented the command. So let me run this particular command. I mean, see here the command is same. I'll zoom this for you. Only we are changing the path of your config properties. Okay, zookeeper.properties. So let's see what is the mistake we are doing. Great. I've run the same command. There is no change. Okay. Now all good. Zookeeper server is up and running. Now what is the next step? We need to start the Kafka server. So to start the Kafka server, the command is same here. See, bin slash Kafka hyphen server start. Only we are changing the path of server.properties. Just copy this, open a new terminal, just run it. Cool, it started the Kafka server. Now we need to create a topic. So what I will do, I will copy the same command. I mean the same command you can use which we use in open source Apache Kafka to create the topic. Only the zookeeper and Kafka server changes to this particular config path. Rest all are same because on top of bootstrap or on top of your broker you are creating the topic. So what I'll do, let's copy the same command. Anyway, it is same, right? Just copy this, go to the terminal, any terminal, just run it. We are creating the topic with name new topic 1. Okay, all good. We are able to create the topic. Now if I list down all the topic, just see the command. See, already I explained in open source Apache Kafka purpose of each word, right? So I'm using the same again for the Confluent Kafka. So let's run it. I just want to describe the topic. I just want to list out all the topics available in this 9092. Can you see here? New topic 1. We're able to see this Java Techie topic and Java Techie topic 1 as well because they both are using the same 9092 and host. Earlier where it started my open source Apache Kafka, and this Confluent Kafka, they are using the same configuration. Okay, so that is the reason you can able to see, but don't focus on that. Can you see the topic which we just created? New topic 1. Cool. Now if you want, you can describe your new topic. Again the command is same. Let me copy this and go to the terminal, run it. Okay, I did a mistake. Control C. I just want to describe it. Can you see here? There is a one replication factor and we have defined the 3 partition. We can able to see that. Okay, all cool. Now let's start a producer message, producer application and consumer application. Then just publish a message to visualize whether we are able to push the messages in Confluent Kafka or not. Okay, so I'll just copy this command to start a producer. Go to the terminal. I can use the same, right? I can use this command K. Now meanwhile I need to start a consumer. I don't want to read it from the beginning. I want to read it because we have not sent anything, right? Now I will go to the new terminal. This one. This will my consumer now. This is my producer. Cool. Just run it. Both are pointing to the same topic. He will publish to the topic 1. This is the producer will publish to the topic 1. Consumer will read from the topic 1. I'll send something. Welcome to Java Techie. Or I'll open my postman. I'll take any payload. I'll send in the form of JSON. Okay, JSON string. You can send any type of data. Okay, so let's open it. I'll take something. Let me take this. Okay, I'm sending some JSON string. Fine. Some random messages. Can you see here? Now if we'll verify, we have sent 3 messages to this particular topic, right? If we'll go and check, the topic is not listed here. I need to refresh it. Refresh the topic. Can you see here? We can able to see our new topic and we have 3 partitions 0, 1, 2, 0, 1 and 2. Okay, go to this new topic 1, run it. Can you see here? All the messages. Whatever the messages we send in the JSON string, each line is published as a individual messages. So this is not the way we can send the JSON. To just show you that we can able to communicate producer and consumer, I am randomly copy paste the JSON string and I am sending it. Okay, so now what I'll do, total number of messages is 9. The offset count is reached up to 8. Okay, and all messages went to the partition 0. 1 and 2 is empty, right? So what I'll do, I will publish, we can give a try to publish a bulk messages to see whether in Confluent Kafka the load is being distributed to multiple partition or not. Okay, so I'll just copy this. I need a new, okay, I can use the same producer. Topic 1 and then I need the location of my download, right? Because that is where my file is present. So cd come out, this is right, close it. Use just.csv, just enter it. Can you see here? It sent all the rows. Now we'll verify whether 1000 row went to the topic 1 in Confluent Kafka or not. Let me refresh this topic. Now if you'll run it, you can see so many messages. Now, did you observe one thing? Some messages went to the partition 1, some messages went to the partition 2, some messages went to the partition 0. Now if you see in the partition 0, total 9 messages received to the partition 0, one received 925. Now rest 75 will be there in the partition 2. All good, 76. Okay, the messages will, or the events will be distributed to the number of partitions. Okay, again we can't guarantee who will get the more messages or who will get the less messages. That will be again managed by the coordinator. Okay, and this behavior is also same in the open source Apache Kafka. Only few of the utility you will find in the Confluent Kafka. Okay, now in my all the upcoming videos I will use the open source Apache Kafka, but if you are familiar now about the Confluent Kafka of community edition, I mean I already show you, right, how we can play with each component in open source Apache Kafka and Confluent Kafka. Now it is up to you. When we are doing any program using the open source Apache Kafka, if you want, you can give a try with this Confluent Kafka as well. Okay, you can install Kafka on any operating system like Windows, Mac or Linux, but the installation process is somewhat different for every operating system. So instead, you will use Docker. I think it's an even better option since you don't have to install the tools manually. Instead, you just need to write one simple Docker compose file which will take care of everything. And the best part is it will work irrespective of any operating system. So it does not matter what operating system you are using, everything will still work. Or in other words, you can say this will act as a platform independent. Okay, and I would say this will be a quick way to get started with Kafka. So without any further delay, let's move into the installation process. So in order to install Kafka on the Docker container, we need two things. We need an instance of a zookeeper and an instance of Kafka. Therefore, we are going to create a docker-compose.yml file, and we are going to define two different services. One is zookeeper service and other one is the Kafka service, and we'll ask Docker to create these two instances for us. Okay, so let's have a look how we can define the docker-compose.yml file and how we can define the services inside that particular YML file. Okay, let's go to the IntelliJ IDEA, or you can create in the any editor. I'll go to the IntelliJ IDEA. I have just created one simple folder, Kafka-installation. I'll create a file called new, click on file, and I will give the file name as docker-compose.yml. Okay, you can keep the extension either YML or YAML. It is up to you. Okay, I will just define YML. Just click on enter. Now in this Docker Compose file, you can define what all services you need. As part of our scenario, we need two services, Zookeeper and Kafka. Okay, and to start any Kafka server, first we need to start the Zookeeper. That is what we learned before, right? We have tried multiple example using the command line interface. So we need to first start the Zookeeper, then we need to start the Kafka. Correct? So I need to define those two services. So first I will define the version, which is 3.1. Then I will define the services. You can define n number of services here. Okay, so that Docker will create the instance for these services, whatever you will define in this compose file. In our case, we need the services called Zookeeper. Okay, now how can I get these services? Simply you need to specify the image name of Zookeeper, but I don't know what is the image name. Simply go to the Chrome browser and you can type Docker Zookeeper. You can find there will be so many Docker images from the Docker hub, but I am using the stable one, this one. Okay, if we will zoom this, this is the image name. Copy this name, just paste it. Define the image. I want this image as a Zookeeper, so that Docker will start this Zookeeper instances by pulling the image from this. Okay. Now once you have defined the images, you can define the name of the container. So I'll give the same name as a zookeeper. Okay. Now once you have defined the image name and container name, next you can define the ports where this zookeeper will run, host port and your machine port. So I will define 2181. This is the default one. So I will specify the same. Fine. We have defined one services. Similarly, we need to define another services, that is Kafka. So let me copy this and I will simply paste it. Second service name is Kafka and images name. You can search the image. Just simply change the name of your service what you want to use. This particular tag having this zookeeper and Kafka. So if you want, I can show you that. In this repository, if you will filter, see here, we have the Kafka. Okay, I'm using the same. Now just change the container name as a Kafka and the default port of the Kafka 9092. Once you have defined the service zookeeper and Kafka, then you just need to define the environment by telling to the Kafka where is your zookeeper up and running. Okay, so simply just define the environments or environment attribute. Just define here Kafka advertised host name and the host is localhost. Okay, now you just need to define Kafka zookeeper connect. Where is your zookeeper up and running? You just need to define that. Okay, so let me quickly define it. Now just define zookeeper. It is on port 2181. Okay, all looks good. Next, once we have created this Docker Compose file, we can execute it using the Docker Compose command. Okay, Docker Compose up. But before that, I just want to show you the feature in ID. If you want to run the individual services, go to that particular service name, and here you can see the option called Docker Compose up Zookeeper. Okay. Similarly, if you want to start only Kafka, just go to this service. I mean this icon. Here you will find the option to Docker Compose up Kafka. If you want to run all the services what you have defined in your file, just run on the, I mean just click on this particular icon. Okay, it will execute all the services defined inside this compose file. Okay, but I just want to run it explicitly in the command prompt so that you will be aware about the command. So what I'll do, I'll go to this particular directory first, cd Kafka installation. Okay, now if I'll check the ls, I have this docker compose yml file. So what I want to do here, I'll simply run the command docker compose, then give the file name which is docker compose yml and of that particular compose file in the background. So that is the reason I have defined -d. Okay, so the main command you just need to run docker compose, give the file name and define op. Okay, just run it. Can you see here? It's pulling the Kafka, pulling the zookeeper. It will take few seconds to download those two images. Okay, if you observe here, container zookeeper started and container Kafka started. Also network Kafka installation default created. It created the default network and it started these two containers. So we didn't run this zookeeper and Kafka from our local binary distribution. Rather, we asked to the Docker to create these two instances for us. Okay. Now to verify whether these two container is running or not, what I can do, first let me check the images. Can you see here? It created the image called Kafka and you'll also find the image called zookeeper. Okay. Now we'll verify whether these two instance is running or not. So simply you can run docker ps. Can you see here? Let me zoom this. So container ID is this, and the name of the container we have defined zookeeper and Kafka. Okay, these two instances up and running. Now what we'll do, let's move ahead one step into the Docker container or Kafka container, and we'll execute the command to see whether the Kafka is up or not. Okay, so for that what I can do, you need to fire the command. Let me clear it. Docker execute integrated terminal and name of your container ID. In our case, the container ID is Kafka, right? That is what we have defined our container name. Next, just define /bin/sh. Before that, just add a dash here. Okay. Now if you'll enter it, now if you'll do the ls, you can find these many folder. Okay. Just go inside cd opt. Now if you'll do the ls, you can find your Kafka binary distribution installed by the Docker itself. Okay, now go inside this particular folder. I'll copy this. Now we are inside the, if you'll check the directory, we are inside /opt Kafka and the binary version. Okay, now if you'll do the ls, you'll find license notice bin everything. Now if you'll go inside the bin, you will find all the script file, shell script file or bash file for Windows. Can you see here? All the shell script file. To start the Kafka, to create the topic, to produce the messages, to consume the messages, everything you will find. Now what we'll do, we'll quickly end of this. We'll just create a topic and we'll publish a message and we'll just consume it. Or we'll just publish a message and we'll verify that in offset Kafka Explorer. Okay. So to create a topic, you know the command. So let me enter it. Simply just run this Kafka topic.sh. We want to create the topic and give the host and the service name of zookeeper, replication factor, and we need partition 1. Topic name is quick start. Okay, let me zoom this. Quick start. Now just enter it. It created the topic called quick start. So we'll verify whether this topic is created or not. So what I can do, I will open the offset explorer, then just click on this. I mean, you just need to give the, see here, if you will see the connection property, I'm giving where is my zookeeper up and running. Now if you'll open the topic, we can see the topic got created, name quick start. So there will be no data since we didn't publish anything to this topic. So to publish to the topic, what I can do, I'll go to the terminal, then I'll simply run the producer command, Kafka console producer.sh, to which topic you want to produce the messages and what is the host and port where your bootstrap server or Kafka server is up and running, right? This is the basic command. We already tried this many times in our Kafka series. So I'll just enter it. Then I'll send few messages. Hi, hello, Java Techie. Then install Kafka using Docker and Docker Compose. Okay, or anything, some number, some random messages. Now, how can we verify whether the messages what I produce is there in the Kafka server or not, or it is there in the topic or not? Simply go to the Offset Explorer. Now, just go to the data. I want to see all the latest data. Just execute this. Can you see here? All the messages what we have just produces is there in the topic. Now, what I want to verify, that is fine. Producer is able to publish the messages to the topic. Now, I want to verify whether consumer is able to consume these messages or not. Okay, so that is again quick step. What I'll do, I'll just open a new terminal. Then I will just It's fine, I can run from this command also. So I'll just execute the command this, then I'll go to the directory cdopt ls. I want to go to this particular directory cd, go inside the bin ls. That's it, right? Now we just need to start a consumer app so that it will read whatever the messages we have published to this particular topic. So simply go to the terminal. What I'll do, I'll open the background here. Okay, now let me clear everything. I'll just run this command Kafka console consumer.sh, read the messages from this topic from the beginning, read it, and where is my Kafka server. Okay, just enter it. Can you see here? It take few seconds and we are able to consume all the messages. Okay, so in real time you can follow this approach where you can install the Kafka, Zookeeper, MySQL, Redis, whatever the services you don't want to install on your machine and you want to play with them, or you are hosted to the server where you don't want to install them physically but rather you want to get it from the Docker. So you can go with this particular approach. All the services you can install through this particular Docker Compose approach. Okay, and this is really needed if your application hosted to the cloud infrastructure, and if you are not using the managed service given by the cloud provider, then you must need to play with this container platform using this Docker Compose. So do let me know in a comment section if you guys have any doubts. So in this tutorial, we'll understand how to produce or publish a message to the Kafka topic using Spring Boot, and also we'll deep dive further to understand how the messages are getting distributed to multiple partitions. Okay, alright. So let's quickly create a new project to demonstrate Kafka using Spring Boot. First, let me create a new project from the IntelliJ itself. Project, define the group ID, artifact ID, version, all the things. Change it to Maven. Let it be JDK 17 is required since we are using the Spring Boot 3.0. Then specify this project name. Next, here you need to choose the correct dependency. So I am going to use the web dependency because I want to expose an endpoint. If I will trigger that endpoint, it will publish message to the Kafka. Okay, that is what I want to design. I need web, and the main dependency you need to add is Kafka dependency. Now if you observe here, there are two dependencies you are getting for Kafka. One is for Kafka stream, one is for Spring for Apache Kafka. Okay, so we are going to use this. Since we are not going to use the Kafka stream for now, we'll go with the Spring Kafka dependency. Okay, I believe that's enough. Now click on next. So next, once the project is imported successfully, since we are playing with the Kafka, first we need to start the Kafka server, and already I explained the order to start the Kafka. First you need to start the Zookeeper, then you need to start the Kafka server, then as per your need, whether you want to create a topic and you want to configure partition count, replication factor, all these steps you can do. But to start the Kafka server, first you need to start the Zookeeper. Okay, so what I will do, I will go to the directory where I install my Kafka. This is what the directory. Then I'll open the terminal. Okay, so I'll start the Zookeeper first. So I already shared the GitHub link where I have defined all the command for the Kafka. So the first command to start the Zookeeper, I will copy this. Then I'll go to the terminal. Fine. Then I will just start the Zookeeper. Okay. Once I start the Zookeeper, then immediately I will start my Kafka server. So for that, I will go to the terminal and I will take the command to start the Kafka server. Then I will open a new terminal. Okay, I can start the Kafka server here. Fine. So if you observe, my Kafka server is started on port 9092. That is the default port. Okay, I just highlight here. If you can see this, let me zoom this for you. 9092 is the default port of my Kafka server. Okay, and this is my zookeeper. Fine. Now all good. All our Kafka ecosystem is ready to start the development. Go to your IntelliJ IDEA, and first I will go to application.properties file, or you can create the application.yml file to tell to this application where is your Kafka server is up and running. If you will not specify that, how your application is know that where is your Kafka is running, so that you will publish the message, right? So that's the reason you need to specify in your application that where is your bootstrap server of Kafka producer is running. Okay, so I'll create a file, I'll name it application.yml. Then I can define here. First I will define my server port. Let's say I just want to define something 9191. Then I will define Spring Kafka producer, then bootstrap server. Okay, and give the URL. You can define multiple server port and host, but since we have only the default one, which is our local host, I will just specify here local host, and the default port is 9092. Fine. Next, let me create couple of packages where you can define our logic to publish the message to the Kafka. Okay. Next, let me create the service class where actually we'll write the code to publish the messages. So I will create a class called, let's say I will give a name something like Kafka message publisher, something like that. Okay. Now this is the class. So in this class, to publish a message to the Kafka or from our application, if you want to talk to the Kafka server, then you need to use some class given by the Spring framework, that is Kafka template. Okay, Kafka template. Define the key and value. For now, let me define the key as a string and value as a object. Let me annotate this class as a @service, and I need to auto add this. Fine. Now here I'll write a simple method public will simply return the message, nothing else. I mean, will simply return the message to the topic. So I'll name it send message to topic. What message you want to send? I will pass it from the controller. Since we have injected the template, now what we can do, using this template we can talk to the Kafka server. So I will just use this instance template dot send method. If you observe, send is the overloaded method. It contains multiple arguments. You can use as per your need. Since I just want to send a simple message to the topic, I will use this second method, overloaded method. I will specify the topic name. Let's say JT or Java Techie. Fine. And then I need to specify what data I want to send to the topic. This one. Now one thing you need to observe here, we have used this template.send method, but if you will take a look into its return type, it is completable feature. Okay, so this is the completable feature. So here, if you want to block the sending thread and get the result about the sent messages, then what you can do, simply you can do feature dot get API call from the completable feature. Then the thread will wait for the results to come, but it will definitely slow down the producer. As you know, Kafka is a fast stream processing platform. Therefore, it's better to handle the results asynchronously so that the subsequent message do not wait for the result of the previous messages. Okay. Now how we can do that? We can do this using a callback implementation. I will show you that how we can do that. Let's remove this piece of code. We'll simply tell to this future object future when complete, when the feature will be complete. Okay, then I will use the lambda. It will give me the result, and also it will give me the parameter of exception. Okay, now I can simply print whatever the things I need. So just add a comma here, and I will just add some print statement. Okay, so here what I am doing, I am just checking if x equal to null. If there is no exception, it means message is sent, and I just want to tag what messages we have sent and what is the offset number of it. Also, if you want, you can also get the partition number where the message went. Okay, so if you see here, there is a method result dot get record metadata dot get not record metadata okay dot you can see here the partition. Okay, you also if you want to print the partition you can do that, but let's make it simple. Okay, I am trying to make it asynchronous so that it won't wait for the result to come, and I am just simply printing the message. This is for success and this is for failure. Okay, that's it. Now this is the method who will send message to the topic. Now I will call this method from my controller class. So I will create a controller class quickly. I'll name it event. Now I need to annotate here at the rest controller. I'll also define request mapping and I'll give some URL here. Then I need to inject the Kafka message publisher the service class. Okay, so I'll just inject private. Let me zoom this. So once you inject the publisher, now I can simply define the endpoint who will publish the message. Okay, so I'll write public response entity of type generic. Let's say publish message. Okay, I'll pass the message in the request URL. Annotate here at the path variable. Also I will define this as a get mapping. Define the URL. I'll just define publish and what message I want to publish. Simple, right? Now what I can do, I'll simply call publisher dot send message to the topic and I will simply give the message name. That's it. But for safer side, I'll keep it inside the try catch. Fine. Now here I'll just return response entity dot OK and some messages. I'll give something like message. Similarly in the catch also I'll just define return response entity dot I can specify the status which will be HTTP status dot internal server error or anything whatever you want to specify. Okay, then I'll simply build it. Fine. I have just handled the try catch here to just track the response or to just track the event whether it is successfully published or not. Fine. Let's say my Kafka server is down and I'm sending the messages, then definitely I will get the internal server error. You can handle it in better way, but this is the simple exception handling I have did here. Okay. So now we are all set to start the server. Okay, I mean application. Now if you observe one thing, we have not create topic manually. Okay, if you observe here, while sending the messages to using this Kafka template, I am just giving the topic name, but I have not created it manually through the command prompt. So whether the Spring Boot will create the topic for us or not, that we are going to verify. If Spring Boot will create the topic on behalf of us, then what is the default configuration he will add, that we are going to verify now. Okay, so all good. Let me go to the main class. Just start the application. So you can observe here it started on port 9191. Now let's go to the postman and try to hit this particular endpoint /producer-app /publish on the messages. Okay, now let me clear this. Let's say I will just pass a message welcome. Can you see here message published successfully? And now if you'll go and check in your console, you can find that is what we have just added in our completable feature. When complete these messages we are going to print. The message we have sent is welcome. Let me zoom this for you. And the offset count is 0. Offset is nothing the position of your message inside the partition. Okay, so that already I explained in the Kafka component and its architecture. So I hope that makes sense to understand this term. Okay, now I'll add some other messages. Let's say abc def ram bimol. Okay, so I have published near to 4 or 5 messages. Now let's see. Go and check in your console. See, all the messages is assigning to the offset, but we are not sure whether it is going to which partition, because even we don't know the topic configuration created by Spring Boot. So let's verify the topic configuration, then I will show you how you can create manually and how you can create programmatically. Okay, so now to describe the topic, what I can do, I will go to the terminal, then simply fire this command, give your topic name, which is Java Techie demo 1. So already all the required command I have shared in this Git repo. Okay, so I will also share this link in video description, so you can use that. Now let me trigger this. So if you observe here, the partition count equal to 1 and replication factor equal to 1. So whenever we are allowing Spring Boot to create the topic on behalf of us, it will go with the default configuration with the partition count 1. It won't give you the correct or proper throughput. If your application is being used by multiple consumer, they cannot able to handle your request concurrently because of this partition count. Now how you can create topic with your own configuration. Let's say I want to go with partition count 5 or 10, 15 as per my needed. Then you need to create it manually. How you can create that? You can go to this, and I have already shared this command. Copy this and just go to the terminal again. Just trigger this command, and you just need to change the topic name. So I will change it to Java Techie. Okay, let me create this. It created the topic for me. But before we use this Java Techie demo 2 topic, first let's verify Java Techie demo and topic, whatever the message we have sent, whether it is there in the topic or not. If it is there, what is the partition and what is the offset, we can visualize. Okay, so to visualize the Kafka ecosystem, I already explained you can use the offset explorer. Okay, just open this, then simply take the connection. Now if you'll observe here, there are two topics, right? Java Techie demo 1, Java Techie demo hyphen 2. Okay, so the first topic we use this demo 1. So if I'll open this topic, if I'll click on the data, and if I'll change it to the new, and if I'll send the request, we can see all the 5 messages we have published, right? Welcome ABC DEF RAM Bimal. Okay, and corresponding offset, and all went to the partition 0 because we have only one partition. Now since we have created the other topic with the 3 partition 0 and 1 2, you can see here. Now let's see how we can send multiple or bulk messages to the topic, so that message will be distributed to multiple partition. So what we'll do, we'll use this topic in our code now rather than using the default topic created by Spring Boot to verify the messages, bulk messages is getting distributed to multiple partition. That is how the increasing the throughput from the middleman of Kafka. Okay, so what I'll do, I'll just go to the code. First I'll change the topic name Java Techie demo hyphen 2. This topic have 3 partition. Okay, so if I'll send bulk messages, let me write some logic to send some bulk messages. So I'll go to the controller. What I'll do, I'll just define a for loop here. Int I equal to 0, I less than equal to, let's say I just want to send 10,000 messages. Okay, that is how I can show you how I can send the bulk message. I plus plus. So here also I will just do some changes. With the message, I'll just append the number. Whatever the message I will send, let's say I send user, then user want to like 10,000 user string message will publish to the Kafka topic. Then we'll verify, since we have the 3 partition, how many messages is went to each partition and how the messages is getting distributed. Okay, this is the simple way to demonstrate this particular concept. All good. Let me restart it. So you can see here application started on port 9191. Go to the postman. Then I will simply trigger here, let's say user, so that it will append user 1, 2, 3 like that. Okay. Now I will send the request which will trigger 10,000 message to the Kafka topic. Send the request. It took 1915 millisecond. Okay. Now go to the this particular offset explorer. Now let me refresh this. Okay. I'll go to this particular topic, and if I'll just verify the data, there are so many messages. Okay. Now if I'll verify each message count from each partition, let's say I went to partition 0, it received 1682 messages. If you want to see the data of those particular thing, you can hit this, all the messages you will get from the partition 0, and you can find this offset here, right? So the count we want to see, it received 1682 out of 10,000. Now we'll verify partition 1, it received 5120. Now we'll see the partition 2, it received 3199. All the three partitions received the message from the producer what we just published now. Okay, so it clearly says that whenever you have multiple partitions, Kafka scheduler or zookeeper will take care to handle the message load and split it into the or distributed into the multiple partition based on their availability. Okay, so you can see here again partition 0, 1 and 2, they both have some information or some messages. So this is how Kafka distribute the load to multiple partition. Now the next thing, in a real time, do we need to create the topic from this command the way I have created here, Java Techie demo 2? It is up to you. In some case, in some industry, they have their own portal to create the topic from the automated way. But if you don't want to do, or if you don't want to create it from the command prompt, then there is a way given by the Spring framework. You can programmatically create the topic. Now I will show you how we can create the topic programmatically. Okay, just go to your code. So what I will do, I will create another package, config. Now I will create a class. Then simply annotate this @configuration. Fine. Then next there is a class given by Spring framework, that is new topic. Using that you can create a new topic. So let me do that. Public new topic. Make sure to import it from kafka.clients.admin. Now you can just return new topic. This is also overloaded method, and you can see here new topic, you can specify the topic name you want to create, you can specify the number of partition you want to use, and replication factor. See, all the required information you can specify here. Let me specify the name, Java Techie demo 3. Okay, and number of partition, let's say I just want to define 5, and replication factor, let's say I just want to define 1. So it will be in the sort, specify the count 1. Okay, let me zoom this. Now just define this @bin. Fine. So we are not creating the topic using the command, or we are not allowing our Spring Boot to create the default topic. Rather, we tell to the Spring whatever the topic configuration we need programmatically. We are telling him this is the topic name I want to create, and this is the number of partition I want to keep as part of my topic, and number of replication factor. Okay. Now let me use the same topic in my services. Fine. Now let me rerun our app. So again it started. Now go to the postman. Let me clear this. Now we have 5 topic. Okay, so we'll verify first whether the topic is created or not. Can you see here? Topic is created with 5 partition. See the partition count 0, 1, 2, 3, 4. We don't have any data because we have not published any message to this particular topic. Now same 10,000 messages again I want to publish to the topic Java Techie demo 3, and we have 5 partition now. Now let's see how many record is going to each partition. There could be possible that some partition will not get any single message also. Okay, because that is not in our hand. That will be handled by the Kafka scheduler, okay, or zookeeper. Now I will just send the request. All the message is published. Let's verify it. Just refresh it. Go to the data, trigger it. Now let's see whether all the partition is getting the messages or not. Partition 0 received 3717. Partition 1 received 1954. Partition 2 received 496. Partition 3 didn't receive anything. Partition 4 received something, 3834. Out of 5 partition 3 didn't receive any single message. Okay, so that is the reason it's not in our hand. It will be decided by zookeeper to whom he need to send the messages. Since we are only sending 10,000 messages, zookeeper assume that okay, these 4 partition is capable enough to handle those kind of messages to increase the throughput. Okay, so that is how they will decide. So this is how you can develop your producer application, and you can also customize your topic as per your required configuration to increase the application performance. Okay, so in my upcoming tutorial I will explain about the consumer part. So we understand producer and we send message to the topic, and topic is being splitted to the multiple partition, so all the message went to multiple partition. Okay, now in my next tutorial I will show you how you can develop the consumer and how concurrently you can handle the events coming from the Kafka topic to this consumer. Okay, so when your producer application will produce the messages, it needs to consume by the consumer. Otherwise, by keeping the messages in a topic without using it does not make any sense. So you need to write a consumer app who will consume the messages from your topic. Now if you observe in the flow, one consumer is listening to 3 different partitions, which is not good. I mean, it don't give you the better throughput. Then how can we design our consumer app to overcome this issue? It's very simple. Just share the workload to multiple consumer instance. So what you can do, we can simply create multiple consumer instance, and then we can group them with an unique ID, so that this ID will indicate the task of a specific consumer group. So now if you observe, we have 3 consumer instance, right? And how many partition do we have? 3. So each partition can consumed by individual consumer instance, which will definitely increase the throughput. Earlier, a single consumer instance is pointing to multiple partition. Now we have a individual consumer instance for each partition of our topic. Definitely this will give you the better performance. But what if I have another consumer instance? Then what he will do? Because already 3 partition is being assigned to 3 consumer instance. Then what the 4th consumer instance will do? Nothing. He will simply stay on bench. The way IT company hires the employee and keeping them in a bench for future project, and once the project came, they assign the employee, right? Similarly, if any consumer instance dies, then this consumer 4 will replace that and start consuming the messages, and this concept is called consumer rebalancing. Okay, so this is what all about the theory of Kafka consumer on the basic level. So we understand the theory. Now let's start implementing our consumer app to understand this practically. Okay, so let's go to the IntelliJ IDEA. So this is the Kafka producer example we have tried last time. Now let's quickly create a Kafka consumer application. Click on File, New, click on Project, click Next, then specify all the required field. Now let's add all the required dependency. I will just add Kafka, Spring for Apache Kafka, and then I will just add web dependency, Spring Web. That's it. Click on Next, click on Finish. So now we have created the consumer application. Now if you observe here, consumer application is the one who connect to the Kafka topic to receive the messages. So you need to tell to your consumer application where is your Kafka server up and running. Then only he can connect to the topic and he can retrieve the messages, right? So first step, you need to tell to your consumer where is your Kafka server is up and running. So go to the resource or application.properties, it is up to you. I am using the application.yml file. Now here you will define Spring Kafka, then consumer, and where is your bootstrap server is up and running. In our case, it is running on port localhost 9092. Make sure before you start your producer and consumer, you should start your zookeeper, then your Kafka server. Okay, and also I will just change the server port here, server port 9292, because I believe my producer is up and running on port 91. Okay, 9191. So I just change it to the 9292. That's it. Now let me quickly create a package so that we can start creating a class who will do the actual logic or who will try to fetch the messages from the topic. Okay, let me create a package. Then we'll create a class. Now just annotate this class with @service. Fine. Now we'll write a method who will do the actual logic to retrieve the message from the topic. Public void. So what I'll do, I need to annotate here @sl4j. Okay, I didn't add the lombok. Fine. I'll create the logger object. Then complete the method. Consume. That's it. Now which type of data we are sending from the producer? If you go and check in your producer, go to the class, we are sending message of type string, right? So you need to specify the type, what messages this method will consume. So I'll specify string message. Fine. Now I'll just add the log statement to print that messages. Logger, or just change it to the log. Just add some messages. Okay. Consumer consume the message and the messages we are receiving. Fine. We are not doing anything. We are simply write a method to consume the message and we are just simply printing them. Now, how this consumer will know from which topic he need to read the messages, that you need to tell to the consumer. Okay. How you can tell that? Simple. The annotation is Kafka listener. Now in this Kafka listener annotation, you can tell to the application or you can tell to this consumer who is the topic from where you want to read the messages. Okay. So in our case, what is the topic we created in our producer application? Java Techie demo, right? We are creating the topic in our config class. This is where we are creating the topic with 3 partition. So you need to specify the same topic name in consumer from where you want to listen the messages. Now all good. Let me start the producer, then we'll start the consumer app. So go to the producer, start it. Once it will up, we'll start our consumer. So producer is up on port 9191. Now let me start the consumer app. Go to the main class and simply start it. Meanwhile, I will open the Postman. Let's check the producer code in our application. Just go to the publisher. Not here. Go to the controller. Just wanted to check how many messages we are publishing. Okay, 10,000, right? That's fine. We can send the 10,000 and we'll see whether it is getting logged in our consumer or not. Then we'll change it. So we'll go and check our consumer app. We are getting the error. Now if you observe carefully, the error clearly says that no group ID found in consumer config. As I already explained, even though you have a single consumer instance, still you need to map it to a consumer ID. But in our code, we have not specified any consumer ID. Okay, that is the reason Kafka is giving error. Hey, just map a group ID to your consumer instance. So if you'll define group ID here, group id, and let me give something like jet hyphen group hyphen 1, something like that. Okay, and also I need to configure this particular group id in YML file or application.properties file as well. Okay, because that is the central place where we are specifying our configuration. So spring, okay, so already we have defined this. So in the consumer section only you can define group id. What is the group id? Jetty group 1. This is the group id we have created. You can give any unique name. Okay, it will just help you to find the role of your consumer group, or to find the role of your this particular consumer group, which task it is doing. That is the reason you can segregate using this consumer or group id. Okay, that's fine. Now go to the listener. We have defined the same, and we have defined same in our config. Now let me restart it again. So consumer app is up and running. Now if you observe carefully, let me zoom this for you. Jetty hyphen group hyphen 1 is my consumer group id, right? This particular consumer group is assigned to all the three partition. Can you see here? Java Techie demo 0, demo 1, demo 2. The Java Techie hyphen demo is my topic name, and partition name append with the number 0, 1 and 2, and all the three partition of my topic is being assigned to single consumer instance by specifying this particular group id. So that is what the first step we have discussed here. A single consumer instance is trying to read from multiple partition. This is the happy scenario what we are trying now. Later we will increase the consumer instance, and we will see whether the each consumer instance is pointing to each partition or not. That is the next step. Okay. Now for now you can read this particular statement to understand. This is the consumer instance, and this is the group id is being assigned to all three partition. That's fine. Let me clear this. Go to the postman. Let me send the message. It will send 10,000 messages, right? It will definitely take few seconds. Message published successfully, and it take 1507 millisecond. And now let's check in our consumer app. Can you see here? Consumer consume the message, user this one. I mean, this is the message, this is the message, and this is my log statement. Consumer consume the message, this. All the 10,000 messages is being consumed. Okay, now how you can sure that all the 10,000 messages what you have published from producer is being consumed by your consumer? Simply go to your offset explorer, then refresh the topic. You will find the Java Techie demo as a topic. Now let me refresh this. Let me, yeah, you can see here, right? This is what our topic, and this is what the consumer group we have created. Now first let's verify the data in topic. So just run it. Now if you will go and check in the Java Techie demo, go inside the partition, you can verify each partition, I mean getting the messages. Partition 0 received 5150, partition 1 received 2346, partition 2 also received something 2505. I mean all the three partition received the messages. Okay, now if you'll go and check in the consumer group, if I will open the offset, can you see here the topic name is Java Techie demo, and message received to all the three partition 102. Okay, and count of each partition messages, each messages in partition, you can see your partition 1 is this much, 0 is this much, and 2 is this much. Now offset is the number of your sequence. Now if you observe your lag is 0. Now all the partition, whatever the messages they have received, they are able to deliver that messages to the consumer. I mean consumer successfully read 2346 messages from partition 1, 5150 messages from partition 0, 2005 messages from partition 2. That is the reason you can see the lag count is 0. There is no message is pending from your producer side to consumed by your consumer. All the messages whatever your producer is published is being consumed by your consumer. Okay, so by seeing this lag number, you can understand how many messages your consumer is not received. Okay, this is what I always prefer to use this offset explorer, because this will give you the lag information. Okay, that's fine. Now what do you understand? Partition 0, 1, 2 received all the messages, but we have only one consumer instance who is listening to these three partition. Now, can we try creating three consumer instance so that we'll verify whether all the three instances is pointing to individual partition or not? We'll do that right away. Let's go to the code. You can create a separate class and define the this particular Kafka listener, and you can specify from which topic you want it to read, but we'll simply create duplicate method to consume the messages, okay, rather than create duplicate class. So I'll just copy the messages. I'll create three consumer instance. Okay, let me zoom this for you. This is the second one, so I'll just define two. I'll define one. Now I created another one. This is 1 2 3, right? We have created three consumer instance. Also, as per the flow I explained, right, if there is a fourth consumer instance, then what he will do? Because we have three partition, all the three partition will assign to each and every consumer instance. Then what is the role of consumer 4? We'll see that as well. Okay, so we'll create another consumer instance for backup. So I'll name it anything. You can give consume 4. That's it. Now I'll just change the log statement, otherwise it is difficult for us to filter out who received the messages. Okay, so I'll just define this is consumer 1, consumer 2, consumer 3 and 4. That's it. Okay, group ID, everything is same. We have just created multiple consumer instance. So we'll see messages will come to, if messages will come to two partition, then two consumer instance should read those messages from the partition. It can be consumer 1 and consumer 2 or 3 and 4, any order. That is depends on the zookeeper coordinator. This is not in our hand. That's fine. So for safer side, what we'll do, we'll just change the topic name and group ID. Okay, I'll change it to the group, jetty group. Same I'll replace in all the method. Also I'll change the topic name. Same I need to do the change in my producer as well, right? So producer will publish the message here, and also in config, right? That's it. So we have created the same three partition. Let me restart the producer. Producer is up. Now let's go and start our consumer. Now if you see the statement, consumer is up and running. Three individual consumer instance is being assigned to individual partition. You can see here, right? Our topic name Java Techie demo 1 -1 -2 0 is nothing your partition number, and it is just giving the group name because we don't specify our consumer instance name. All the consumer instance we are wrapped inside a group ID. So you can see instance 1, instance 2 and instance 3 is pointing to three different partition from the topic. Now let's verify that right away. Okay, clear it. I'll send the request. Now my producer will publish 10,000 messages to the topic, and the messages will distribute to three different topic. Okay, now then we have three consumer instance. We'll see whether all the messages is being distributed to individual partition and consumer instance combination or not. So go to the postman, simply hit the request. It published the 10,000 messages. First let's verify how many partition received the messages. Okay, then based on that we'll validate our consumer instance. Go and check here. Let me refresh the topic. Also let me refresh my consumer. We have the new consumer jetty group. We'll verify here only. Okay, partition 1 to 0, all three partition receive the messages. There is no lag. It means there should be three consumer instance log statement we can see. Okay, if you are not seeing three consumer instance log, then our concept is wrong, what we discuss is wrong. Okay, so let's verify it right away. So how we can filter it? Simple, right? That is the reason I have changed the first statement. So I'll just filter here. Consumer 1 received 2445 messages. Now we'll see who else received the messages. Does consumer 2 receive? No. Consumer 3? Yes. Consumer 3 received 2371. Okay. Now we'll see consumer 4 also received something. Yeah. 2176. So what we cleared here? We have 4 instances. Consumer 1, 2, 3, 4. Consumer 1, 3 and 4 receive the messages. You can see in 4 we can see some messages, right? And the count you can see here. Now if we'll change it to the 3, consumer 3. 3 also receive the messages, right? Now if we'll change it to the 1, 1 also receive the messages. But 2 consumer is not receive the messages. Okay. Consumer 1, 3 and 4, only these 3 consumer instance receive the messages, not this guy. Why? Simple statement, right? We have 3 partition. That is the reason it assigned to the 3 consumer instance. 1 consumer instance, 2 consumer instance, 3 consumer instance. If message is being pushed to only 2 partition, let's say partition 1 and partition 2, then only 2 consumer instance will print the statement. That is how the Kafka maintain the balance between the partition and consumer instance. Okay. Now what I'll do, the order is not same, right? Now this time consumer 2 didn't receive the messages, but there is no guarantee that when the message will come next time consumer 2, 3, 4 or 1, 2, 3 like that, anyone can receive it. Okay. We'll just verify it right away. Now I'll again send 10,000 messages. Fine. Now we'll see who are all receive the messages. Consumer 3 received the messages. Fine. Consumer 2, no, it didn't receive. Consumer 1 received. Consumer 4 received. Okay. If we'll try many times, there might be, you can see the change in order. Okay. It can be 1, 2, 3 or 3, 2, 1, any order. We can't predict it. It will be decided by coordinator. That's fine. So I believe you are pretty clear with this concept. Okay. Number of partition we have, number of consumer instance, make the mapping and get the messages. That is the simple statement. Okay. But just keep a note, in real time you should not write multiple consumer instance like this. Okay. So this is just I give you the demo to give the clear picture about this partition and consumer instance mapping. In real time, you can make it in a better way by implementing the concurrency. So you can design or you can increase the throughput of your application. Okay, just keep a note again. This is just for the demo purpose. So you should not write the code like this in your consumer. That's fine. Now let's understand, if I have published 10,000 messages to the topic, whether all the messages is being consumed by my consumer or not. Let's say producer published the 10,000 messages, but in between my Kafka consumer is shut down. Then that time, how can I verify that how many messages my consumer received or how many messages he didn't receive? That is what the lag we just discussed now, right? But let's prove it. I mean, we'll forcefully stop our Kafka consumer and we'll validate how the lag show the exact behavior or not. Okay, or whether it shows the exact number or not. Fine. So what I'll do, I'll just open my Postman. So I'll keep this in two different section so that I can quickly stop my consumer. Okay, cool. So let me clear everything. I'll send the request, then immediately I will stop it. I don't know how many messages is being published, because from the producer we have published the 10,000 messages. Okay, so the topic name is also same. Let's verify it right away. Go to the Offset Explorer, just reconnect it, open the topic Java Techie demo 1, go into the partition, but it won't give you any clue here. If you look into the topic, better you go to the consumer. There is no lag because we are not able to shut down immediately. Okay, so what I'll do, I'll publish more messages so that I will get enough time to shut down my consumer. So I'll go to my producer application. Then this is how many? 10,000, right? I will send 1 lakh messages. And also I'll just change my topic name. Go to the config here. Okay, we did change in config. Change this topic name. Now go to your consumer code. Meanwhile, let me start my producer, right? We have did the changes. Just restart it. I'll go to the consumer. In consumer also you need to change the topic name. Let's say 2 only, right? And I'll change the group. Jetty group hyphen new. Let me specify in all the instance. Fine. We have changed the consumer group and we have changed the topic name in both producer and consumer. And we start our producer. Now let me start my consumer. Okay. Consumer is up and running. Let me clear everything. Let me send the request now. Now it will send 1 lakh record to the Kafka. Okay. Now send the request and meanwhile I will stop it. I'm able to stop or not, I'm not sure, but I've tried it. But let's see. I will just reconnect it, okay, so that it will refresh everything. Go to the topic. This is the topic newly we created, right? Go to the consumer. Jetty group new is there. Yeah, we are able to deliver it. Java Techie demo 2. Can you see here? Not don't verify the demo 1. This is the recent topic we created. In demo 2, partition 1, it received 32,358 messages and only 976 message is being consumed by your consumer. That is the reason you are able to see the offset count. Rest 31,382 messages is not being consumed by your consumer. Okay, you won't find those messages in your consumer section. Okay, now if you'll see the partition 0, it received 32,766 messages. It was able to deliver 3,217 messages. 29,549 messages is not being consumed. Producer is able to publish the messages, but somehow your consumer is shut down that time, so he is not able to receive those messages. Okay, now you can easily identify, right, which partition is don't which partition messages is not being consumed by your consumer. So in real time, in production issue, you might need to republish your messages, or you need to publish your messages again to resolve such kind of issue. So if you have this tool, at least you can figure out, right, the number of messages in which partition. Okay, that will give you the clue and you can publish the messages from that specific partition. Okay, and you can see here partition 2, 34,000 messages he received, but he only published 3,257 because these are the messages is being consumed by consumer. 31,620 is not consumed. Okay, so this is how you can figure out the lag in your producer and consumer. So it will make your job easier, or it will give you the better productivity while analyzing the issue on Kafka. Okay, don't worry, I will also tell you in my upcoming tutorial how you can retrieve a specific messages from the partition. We'll go in deeper, okay, with the code in my upcoming session. So I hope you are clear about the consumer and consumer instance and partition mapping and how to verify the lag in the Offset Explorer 2. In the previous Kafka tutorial, we understood the complete Kafka PubSub mechanism, right? Where we publish the plain string message to the topic, and from the topic our consumer application consumed it. Even we deep dive more to understand partition and consumer group mapping with examples. But the PubSub system which we designed, will it accept any data type to publish and consume the event? The answer is big no. Let's prove it right away, then we'll find out a solution for it. Okay, so to verify this behavior, instead of sending the string message to the topic and consumed it, let's send some object, or let's create some Pojo class which we want to send to the Kafka topic, and we want that Pojo need to be consumed by my consumer. So for that, what I'll do, I'll simply create a new package, DTO. Now I'll create some class here, let's say customer class. Now let's define couple of fields. So we have defined ID, name, email and contact number. So we added the lombok, right? So I can use the @data annotation to avoid, okay, we have not added the lombok. No worries, go to your pom.xml and then you can add the lombok dependency. Just update it, that's it. Now we can import this statement. So we no need to write the getter and setter because we already added the @data annotation. That's fine. Now I want to send this customer object to the Kafka topic from the producer, and I want this customer object need to be consumed by my consumer application. So let's do that. Go to the publisher where exactly we are publishing the message. So let me go to that class. We have defined the publisher, right? So I don't want to touch the existing code, let it be. I'll create a new method. So I'll name it, let's say send events to topic, and here I don't want to send the message, I want to send the object which is customer. Fine. Now everywhere I need to change it. Fine. So I will also change the topic name, that will do later. Now let me send the object. So this is the exact place where we are sending the object. Okay. Earlier we are sending the string message. Now we are sending one custom object which is customer. That's fine. Now we'll call this method from our controller. Go to the controller class. Then simply write another endpoint. So I'll write something like public void send events. Okay. And what type of event I want to send? Customer object. Now simply I can call publisher dot send events to the topic and customer, and I need to define this as a endpoint. So what I'll do, I'll just define post mapping because I want to send the object from the postman, and I need to annotate this at the request body. That's it. I need to define the URL here, publish. Okay. So what we are doing here, from the postman we'll send the customer object in the form of JSON, and then we are giving that to the Kafka template to send this particular customer object to this given topic. Okay. So what we'll do, we'll also change the topic name. So go to the config. This is the place where we are creating the topic. I'll name it Java Techie demo, and go to the controller class, not controller, go to the publisher class. There also we need to change the topic name. So we want to send the customer object to this particular Java Techie demo topic. Okay. Now once we send it to the topic, who will consume it? Our consumer. Now also we need to tell to the consumer, hey consumer, please consume customer object instead of string, right? So I also need to do the code change in my consumer. So go to the consumer application. First let me copy this DTO class. In consumer also you need to tell, right, what need to be consumed. So what I'll do, I will also comment all the consumer group related stuff. This is my consumer. He will point to the Java Techie demo, what I have defined just now in my producer, and instead of string message, we need to tell to this consumer, please consume the object which is customer. What data type you need to consume, you can specify here. Okay. So I'll change the method name to consume. So it is crying because we don't have the customer class in this particular project. So rather than keep the same class in both producer and consumer application, you can create a multi-module project, and you can create a common module, and you can keep all the common DTO or Pojo class. Okay. But for this demo purpose, I am just adding it. So we have added the customer. Again, we don't have the Lombok dependency here. So just go to the producer and copy the Lombok dependency. Then simply go to the consumer pom.xml and paste it. All good. go to the listener and just import the statement. So I will just print here customer dot toString. I just want to print it the plain string. Okay. Consumer consume the events. Fine. We are also specifying the topic name and group ID. So group ID you can give any name. That's it. Just go to the producer once again. Let me verify. We have defined this, right? Also, what I want to do, I will keep this in try catch so that if there is any exception while publishing the event, we can easily catch it. Just add another bracket. That's it. So here what I will do, I will just print it. Sys out. Let's say error. And what is the error message we got? If there is any, get message. That's it, right? So I have started my Zookeeper and Kafka server. That is the first step you need to do before you start your application. Now we are all good. Let's run our application. So let me start the producer app. Once it will up, then I will quickly start my consumer app. So producer is up on port 9191. Go to the consumer and just start it. So it is up and running. Also it clearly says that the group ID what you have created is being assigned to the topic of 3 partition 0 1 2, because we are creating Java Techie demo topic with 3 partition. That is what we have written in our Kafka config. That's fine. Let me clear this. This is my consumer, right? And go to the producer. Let me clear the console. Fine. Now what endpoint we need to trigger? This particular endpoint /publish, and you need to give the customer as a JSON. So I'll go to the postman. Let me check the endpoint. Producer app, yeah. This is what the producer app and publish. So I will send the customer object ID, name, email and contact number. Now let me send this object to the from the producer app to the topic. Let's see what is the result we are getting. Status is 200. Let's see what if there is any error. Can you see here? We are getting the error here. Can't convert value of class this DTO customer to Apache Kafka common serialization string serializer specified in value serializer. What it says, usually when we are sending the messages to the topic, it will always accept byte array as a input, because we are serializing the object. We are sending the object over the network to whom? Topic. So if you look into the presentation, from the producer to the topic, we are serializing the data, okay, in the form of object or in the form of JSON. But in the consumer perspective, we are deserializing the data from producer, which we are sending the byte array over the network to the topic, and in consumer it consumes the byte array from the topic. So this is the part of serialization and deserialization concept, basic core Java. If some object you will send over the network, that must need to be serialized, and if you will read that particular object, then that must need to be that concept is called deserialize, right? That is what exactly we are doing. Producer is serializing the object to the topic, and consumer is deserializing the object from the topic. So that is the reason we are getting the error here, because Kafka looking for byte array to be input. So that is the reason we can happily play with the string without adding any configuration. If you send any string, that will be converted to the byte array and will publish to the topic, and consumer can consume that byte array and can convert it to the string. But if you want to play with the different type of object, then you need to tell to the Kafka, hey Kafka, while doing the serialization, please use this serializer. Or in the consumer, you can tell him, hey consumer, while deserializing that particular object, please use the deserializer what I am giving to you. Tell that I am sending the customer object, please serialize it, and consumer need to tell to the Kafka, hey, I am expecting consumer object, please deserialize it. Now how you can tell to the Kafka? Very simple. Just go to the application.yml file. You need to mention in both producer and consumer, because from the producer you are serializing the data, and from the consumer you are deserializing the data. Okay, So go to the resource application.yml. Let me zoom this for you. Now here you can tell him, hey Kafka, please use this key serializer. And what is the key serializer? I'm sending the key in the form of string. So use this string serializer to just convert the key. Okay. And for value serializer, use the JSON serializer. Just specify that. Very simple. So I am sending the key in the form of string. You just play with the string serializer. But the value what I am sending the customer object, for that please use this JSON serializer, because I am sending in the form of JSON. You please take that JSON and send it to the topic. Okay. And now same thing you need to tell in your consumer also. So go to the consumer, go to the application.yml. Now here in the consumer also you need to tell him what is your key deserializer. See the word here, see the key here. In consumer we are deserializing the data, right? So that is the reason key deserializer. What is the key deserializer? That is the same string deserializer, right? So just define it. Now what is the value deserializer? Same JSON deserializer. Just define that. Can you see here? Key serializer, key deserializer is the string deserializer, and value deserializer is the JSON deserializer, because we are not giving any key as per our example. Okay, we are playing with the value, so it's fine. You can keep string serializer and deserializer as a key for now, but we are sending the object, so serializer and deserializer must be JSON one, because we are sending the object in the form of JSON. Fine, all good. Now let's run our producer and consumer to verify whether the way we have configured for the object it is working or not. My Kafka is able to publish the object to the topic, and my consumer is consume that object from the topic or not. Okay, so very simple. Just restart. Go to the producer. First restart it. Then go to the consumer. Here also you can simply restart it. Both producer and consumer is up and running. You can see here, this is the consumer. Let me clear the console. Go to the producer. Let me clear the console. That's fine. Now let me send the request. Okay, they are getting status code 200, and then let's see whether is there any error. There is no error from the producer. Producer successfully sent this particular object. You can see here. Okay, because we are just printing the two string. Now let's verify in the consumer. There is a exception in consumer. Let me stop it now. Let's see what is the error we are getting from the consumer. Okay, the class com.javatechie.dto.customer is not the trusted package java util java lang. If you believe this class is safe to deserialize, please provide its name. If the serialization is only done by a trusted source, you can also enable trust all. Okay, so very simple. Okay, the exception it clearly says that the DTO what you are sending or what your consumer is trying to consume is not a trusted package. So you need to tell to the Kafka, hey, if you are getting any object from this particular package, please accept it, please listen to it. Okay, that is what you can define. So just mention that in our YML file. So what I'll do, I'll tell here properties spring JSON, fine, trusted, and specify the packages, which packages you trusted to use or you are allowing your consumer to read that. So what you can do, for now our package is com.javatechie.dto. If you want to include any kind of package, just define the star instead of specify the single package name. Okay, com.javatechie.dto. Now let me restart the consumer. Producer is up and running. He is able to publish the message. There is no error, but consumer was crying, so we fixed it. Let's see whether it is able to consume or not. Yeah, can you see here? Now my consumer consumed the previous event, which is the object. This is what we have sent, right? Now to cross verify it, let me clear this. Let me clear the producer as well, and then what you can do, let me publish some different event. Okay, fine, let me send the request. Go to the producer, send the messages to the topic. Now go to the consumer. Can you see here, consumer consume the event? This is what just now we sent, right? We're able to consume it. Fine, all good. We're able to play with the object from the producer to the consumer. But is there the only one way to play with the object by defining just the serializer and deserializer in application.yml file? No, you can customize that by defining your Java based config class. Okay, rather than add the key and value or whatever the properties in the application.yml file, still you have option to go with the Java based configuration if you want to do any customization. Okay, I will also show you that part how you can go with the Java based configuration. First, let me comment this piece of code because we are not going to use the application.yml configuration. We want to write our own Java based configuration. Go to the producer as well. Let me, not all actually these things. Fine. Now go to the config class, which is Kafka producer config, and then here you can define your own configuration. When I say own configuration, whatever the things key and value you have defined in this application.yml, same things you need to configure in the Java code. I mean, you need to create a bin of it. Okay, so I'll show you how we can do that. So first, create a producer config map. So public map of string object. Now create a object of map. Now all the key whatever we have defined in application.yml, that needs to be configured here. So you can define like this. Okay, producer config, what is the bootstrap server, localhost 9092, what is your key serializer, what is your value serializer. So you just need to define this at the rate bin. Fine. Now by giving this producer config, you can create producer factory object. So public, now simply you can return here new default Kafka producer factory, and you need to give this config whatever you have defined about your Kafka server, serializer, all the things. Okay, so just define that config and annotate this at the rate bin. Now again you need to create Kafka template object by giving this producer factory. Now your Kafka template will have all the information. Okay, because he is not going to read from YML, he is going to read from this config map. So let me create it. Just define this at the rate bin. That's it. Okay, so we define the config map where we have defined all the key and value. Then we created the producer factory, and then we give that producer factory to the Kafka template. Now same things you need to write in your consumer as well. In consumer also you can specify the consumer config map by defining all the deserializer property and all the bootstrap server related properties. Okay, so that is also straightforward. What is the error here? Missing return statement. Okay, I need to return that map object. Fine. Now go to the consumer and do the same kind of configuration. So go to the consumer app. We already commented all the key and value from the application.yml. Now what I'll do, I'll create a new package. Then quickly create a class. Fine. Just annotate this at the rate configuration. Now again here also I need to define a consumer config map by defining all the key and value. Key deserializer, value deserializer, trusted packages, bootstrap server, group ID, everything you can configure here. Okay, so just go to the config class, just define a bin. Now you can create the object of a map. Now you can define all the key and value. So name it props, then just define all the value. Okay, so we have defined bootstrap server, key deserializer, value deserializer, and trusted package. So annotate this @bin. Next, you need to define a consumer factory by giving this consumer config. So quickly create that class public. Now return new default Kafka consumer factory and define the config, which is nothing, consumer config. Fine, define this @bin. Now you just need to define the container factory, Kafka listener container factory. Okay, so just define that Kafka listener container factory, and we are creating the object of it, and we are giving the consumer factory here. Okay, this is the simple way we are creating the consumer config, consumer factory, and consumer listener. Okay, or Kafka listener. So the advantages of using this Java based config: if your application is straightforward, you don't want to do any customization, then you can happily go with the application.yml file. Okay, but for example, let's say you want to access a secured Kafka cluster which will be HTTPS. Okay, then in that case you need to define all the certificate and all in your producer config place. Okay, you need to define the all the SSL related information in the config class. You need to manually configure them, but that you cannot do using the application.yml file. Okay, but if you check in the consumer, there also if you want to set the concurrency level for your consumer, that you can configure here in this listener container factory. That things cannot be done using the application.yml file. So it's pretty simple. If your approach is straightforward, just to push the event to the topic and consume it without any customization, you can go with the application.yml file. But if you want any customization, then you can go with the Java based config approach. Okay, so all good. Now what I'll do, I'll just restart both producer and consumer. So it seems application is up and running. You can see here the consumer. This is the group assigned to the 3 different partition. Let's see the producer. Yeah, producer is up and running. Let me clear everything from the consumer. Clear everything. Now we comment out all the application.yml based configuration, and rather we created our own Java based config, right? So I'll go to the postman. I'll change something 123, name John, some number. Okay, now let me send the request. Status code 200. Go to the producer. Can you see here? Producer is able to publish the message. This is what the messages. Now let's verify whether consumer is consumed it or not. Yeah, can you see here? Consumer consumed the event, customer ID 123, name John, email is this, contact number is this. Okay, so this is how you can play with the object in Kafka. I mean, you can serialize and deserialize any type of object in the form of JSON using the Spring Boot Kafka. Okay, so I already explained both the approach, application.yml and Java based config. So just choose them based on your need. So we'll start with brushing up Kafka internal workflow, and then we'll move into the Kafka partitioning demonstration. Okay. So in Kafka ecosystem, once producer send bulk messages, it will split into different partition. Okay. So let's say I have sent thousands of messages, then each and every message can't be guaranteed that it will go to the same partition. It will go to the multiple partition, the number of partition we have in our broker. Similarly, consumer will consume from all the partition. So this is the typical Kafka PubSub mechanism, right? Now, how you can ensure your message go exactly where you want them to go? Maybe you want to optimize the data processing or improve load balancing. Then how you can control that? I want my producer will send all the messages to a single partition, and same I want my consumer to read from a single partition. How you can make the control on this partition? That is what I am going to demonstrate in this video. So this is the Kafka producer example, and here we have the Kafka consumer example. This is what the example we are starting learning from the Kafka series beginning, right? I am taking the same example to just demonstrate on this Kafka partitioning. Okay. So what we'll do, First I will create a topic with couple of partition. Then first we will see the general behavior or the default behavior, how the messages are getting splitted to the different partition. Then we'll understand how we can make a control on that, how I can send message to a specific partition rather than sending it to all the partition. Then we'll move to the consumer and we'll read from a specific partition. Okay, so first let me create a topic. So you know the command to create the topic, right? Kafka topic sh, then provide the topic name and then provide the number of partition and replication factor. So the topic name I am creating here, Java Techie hyphen topic. Just enter it. So now this topic is created with 5 partition count. Okay, can you see here? The partition count is 5. It means now we can distribute our messages to different 5 partition. Fine. So I will copy this topic name. Then I will go to the consumer. I will just change here. Then I will go to the producer. I will just change here. Now simply start your producer and start your consumer. But make sure before you play with your producer and consumer, you should start your zookeeper and Kafka server. Okay, so I have already started both the server. Now I have started my producer and consumer. Then we'll publish the message and we'll verify. Meanwhile, I will open the offset explorer. Then I will refresh the topic. So we created this topic, right? Java Techie hyphen topic. I'll just go inside this topic. There is no data because you have not published anything, right? So I cannot see anything here. Let's see if the producer and consumer is up. So producer is up and running. Also consumer is up and running and the consumer group is assigned to the 3 partition of my topic. Sorry, 5 partition of my topic. Can you see here? 0, 1, 2, 3, 4. That's fine. Just go to the producer and we'll just publish couple of messages. So this is what the messages, this is what the method I want to execute, who will use the template to send the messages. Now if I'll see here, this is what the controller. Now here I am sending 10,000 messages. So if I'll send bulk messages, then only I can differentiate, okay, all the messages is going to different partition. If I'll send one messages, then simply it can go to the any single partition, right? So that is the reason I am sending the bulk messages here. And yeah, I need to hit this particular endpoint. So let me go to the browser or I will go to the postman. This is where the endpoint. I will send some messages like welcome. Okay, now let me send this. So all the message has been published here. You can see the messages. Now to verify that okay, all the messages is goes to the topic, I will go to this offset explorer and I will simply refresh this. Then if I'll execute this, I can see bunch of messages, right? And now let's see how many messages went to each partition. So the number of partition we have is 5. Can you see here? 0, 1, 2, 3, 4. Begin from the 0, it is 5. Now let's see the number of messages in each partition. Partition 0 contains 2242 messages. Partition 1 contains 3206. Partition 2 1843, partition 3 709, partition 4 2001. Okay, we have sent 10,000 messages. Now different messages went to different partition and we can see the number of messages hold in each partition, right? So now that is what the typical producer flow. Whenever you are publish the messages will distributed to different partition. But I want to make the control here. I want to send messages to a single partition. From this topic, I might need to perform the data processing or optimization. So I might need to send the messages to a single partition. Let's say I want to send to the partition 3. How I can do that? That is what we are going to learn here, right? So simple thing, you need to tell to the Kafka template while sending the messages to which partition you want to put these messages. That thing you need to tell to the Kafka template. Now how you can tell that? Simple. Go to your code, go to the Kafka template where exactly you are sending the messages. Now here, if you'll open this send method, this is the overloaded method in the template class. Can you see here? Topic and data, topic, key and data, and here is the method topic. Now you can tell here which partition you want to send your messages. You can specify the partition along with the key. Key is something which will help you to avoid duplicate message in Kafka, that will cover in the separate session, but this is where the method you can use to specify to which partition you want to send the messages. So just do the simple code change, go to the publisher and tell that okay, I want to send to partition 3 and just pass the key. I mean, for now I will pass the null. I don't want to play with the key at this moment. So now all the messages will send to this partition. So shall we verify that? Simple thing, just go to the controller. I'll just reduce the message count. I want to send 100 messages. Okay. Now it will go to the partition 3. So just verify we want to send into this partition. The current message count is 709 and we will push the 100 more messages. Okay. So simply I will just restart my producer. So producer is up and running. Now go to the postman. I'll just send some different message. Let's say user, and it will trigger 100 user messages. That is what we are just looping in the code, right? We are sending 100 with the user count. User 1, 2, 3 like 100. Now let me send the request. All the messages has been sent. Can you see here? Send message user 93 and this is what the partition. And also if you'll observe in the consumer, okay, what is the problem here? Okay, so that's fine. We'll come to the consumer because we have defined here object and we are sending the string. That is the reason this consumer is crying, but we'll do the code change once we'll demonstrate the consumer part. Okay, that's fine. Now just go to the offset explorer. See, the count is 709, right? And we have pushed 100 more messages. So just let me refresh this. Then simply come to the partition 3. Can you see here? The count is 810. Earlier it was 709, right? Now all the 100 messages is come to partition 3 only. Now similarly, this is how you can manage in the producer part, and you can specify to which partition you want to send the messages like this. You just need to specify the partition number. That's it. Now this is what we understand from the producer perspective. Now whatever all the messages we are sending to a partition or the broker is being consumed by my consumer, right? Now I don't want my consumer to look into all the partition. I want to tell to my consumer, hey consumer, can you please read into a specific partition, for example from partition 3 or partition 2, not from all. How I can do that? We understand from the producer perspective how to push the message to a specific partition. Now we just need to start implementing from the consumer perspective. How can my consumer read from a specific partition? Okay, so it's very simple. You just need to play with the annotation. Just go to the consumer. Okay, let me stop this first. Then I will just do one thing. I will just copy this, or I can create different instance. Okay, I'll take the input as a string because that is what I am sending from my producer. So it found the object which is not able to deserialize. So that is the reason we are getting the error in the consumer. That is fine. Now here in the listener, here exactly in the Kafka listener, you need to specify from which partition you want to execute this consumer to consume the messages. That is what you can just simply define by just writing the topic partition. Okay, now in this topic partition you can simply just define here @topic partition. Now you just need to define the what is the topic name and what is the partition count you want to read. The topic name, you can define the same topic name from where you want to consume, and then you can just define the partition count. The count I want to read it from, let's say from partition 2. Okay, I want to read it from partition 2. That's it. So this is how you can control from your consumer perspective to read from a specific partition. Okay, that's fine. Now let's verify that. So now I'll just use the different topic, Java Techie topic 1. Fine. And then Okay, let it be. I mean, better I will just comment this. Okay, now also go to the producer and I will just change your Java Techie topic 1. Rather than doing like this, what I will do, I just want to send messages to the different partition. Then I can prove that okay, my consumer is reading from the specific partition what I have mentioned there. So for that, what I can do, Kafka template, or what I have defined template, right? Template dot send messages to, I mean, I'll just simply copy this, right? So what is the messages? I'll just define, let's say hi, then something, some random string. Okay, I'm sending multiple messages to the same topic to different partition 1, 2. Okay, first let me see what number you have specified, 2, right? So I'll send more messages to the partition 2. So I'm sending to all the partition, but I want my consumer to read from only these two partition. Okay, I mean, this is the same partition. My consumer should receive only these two messages because these two messages went to partition 2. So just change the messages. Okay, so welcome and YouTube should my consumer consumed. I mean, that is what we can find in my consumer console. Let's verify that. So looks good. We have specified the topic name correctly. Now we just need to create this topic with 5 partition. Okay, so go to the terminal, just run this. The topic name the same, Java Techie topic 1. Fine, the topic is created. Let's verify that topic is created. Yeah, topic is here. We don't have any messages. It contains 5 partition. Fine. So what I'll do, I'll just start my producer and my consumer as well. So both are up and running. Let's verify the producer. All good. Let's go to the consumer. In consumer, if you observe the console statement, consumer client ID, this is the consumer group. Group ID is this. Resetting offset for partition Java Techie topic 1 2. Can you see here? This is the topic name Java Techie topic 1, and it is only listening to partition 2. That is what you can see in the statement itself. Page position offset from the 0. I mean, it's just telling that okay, read it from the partition 2. That is what I can understand from this console. Now let's hit the endpoint and we'll verify. I'll send some messages. Okay, because anyway it is not going to print. We have hard coded the value while sending the messages. Send the request. Message has been sent. Now if you will go and check in the topic, just open the data. Why it send a lot of messages? Okay, oh, it's sending on the loop. Yeah, that's fine. But let's see the number of messages in the partition 2, 20202. Now let's see the consumer. Go to the consumer. See, consumer only consume the method, I mean messages welcome and YouTube, because it's in the loop, so it's send multiple, I mean 100 messages. So can you see here? It only receive welcome and YouTube, because only YouTube and welcome, these two messages we are sending to partition 2 in our producer. Can you see here? Welcome and YouTube. So it is clearly stated that my consumer is listening to only partition 2, because I cannot see this hi, hello, Java Techie, these messages in my consumer console. Okay, so we cannot, let me filter it. Okay, we have not see this, no, no, right? But only welcome and YouTube. Can you see here? The count is itself is 101, and YouTube it should be same 101. Okay, that's it. I mean, this is how you can play with the Kafka partition to specify while publishing the messages and specify the partition while consuming the messages. This is sometimes required whenever there is some message event failed in the production. You might need to republish the event. Okay, and that time you might need to play with this partition kind of concept. So just give a try and let me know in a comment section if you have any doubts. if you remember, in the last Kafka session, we have designed our Kafka producer and consumer application, right? So in this tutorial, I will guide you how to write Kafka integration test with test containers. Okay, all right. Being a developer, always writing a Kafka integration test can be frustrating because that's mainly due to the complex test configuration that involves for registering the consumer and producer or to read and write messages, isn't it? And also, without proper integration testing, you cannot be confident about the stability of your production environment. So to leverage that, we can use the test containers, which can reduce test configuration to almost zero and not worry about how to read and write messages from and to Kafka when writing a test case. Instead, a developer can entirely focus on only testing needed functionality. Okay, so if you are not aware about what is test containers and how to use it, then I would strongly suggest you to check out this particular video in my YouTube channel, Springboot 3 integration testing with test container, where I have explained in detail by taking the example of MySQL using the test containers. I will also share the link in the video description for your reference. Okay, so without any further delay, let's circle back to the demo. So let's get started. So before we start writing the test case, first let's verify whether our producer and consumer example application is working or not. So I have started my producer application and also I have started my consumer application here. And if you observe here in the terminal, I have started my zookeeper and Kafka server. Okay, that's enough. Now if we'll go to the producer app, in the producer application, we have defined the controller. From this controller method, we are sending the customer object to the topic. Fine. So the endpoint is /publish. Let's go to the postman, and I have this particular endpoint with this particular payload. Now just trigger the request. Status code is 200. Now let's verify in the consumer whether that particular object is received or not. Yeah. Can you see here? Consumer consume the event this is what we are sending from our producer 101, name is Basant, email ID and contact number. So all good. Now let's start writing the test case. For that, I don't want to use my Kafka which I installed on my machine, so I will stop everything. I will stop my consumer and producer as well, and from the terminal I will close my zookeeper and Kafka server. Because I am not going to use this particular Kafka instance, I want to take the help from Kafka test containers to spin up a new Kafka instance for me. So I will show you that how we can do that. So let me close everything. Now the local Kafka is shut down for me. So what I will do, very simple, just go to the pom.xml. In pom.xml, we just need to add the test container specific dependency. If I will open it, so I have added the test container dependency, then test container for Kafka, and I have added the Jupyter. And also I have added this utility to just pause for some time. I mean, whenever I am running the Kafka producer and consumer, I want my thread will pause for some specific second or for some time interval. That is the reason I have just added this utility. Okay, I'll tell you in the code whenever we will implement this. That's fine. Then just update your project. Then what I want to do, I want to disable this config class because I want to load it from the application.yml file. So I will just uncomment this. That's it. Just go to the test class and start writing your test case now here. Okay, let me close everything. So first step, we can just run this particular test case in random port. Okay, so I'll define web environment. There is something called random port. Then I just let me zoom this for you. Then I just need to annotate here at the rate test containers. By adding this annotation, I am telling to the Spring Boot test that this particular class is using some container. Fine. Now, which container I want to use? I want to use the Kafka container. So for Kafka container, from where you will get this Kafka container? Just go to this documentation. You can copy this and then simply just paste it here. We are using the Kafka container. By saying to the Kafka container, hey Kafka container, can you please bring this specific Kafka version for me 6.2.1. If you don't want to specify any Kafka version, just tell that, hey container, can you give me the latest Kafka version which you have with you? That's fine. You can define the version whatever you want here. Okay. Now annotate this at the rate container. Next, since we have created the Kafka container, we need to configure the Bootstrap server. So for that, I will simply write a method public void, let's say init Kafka properties or something like that. Then you need to just pass your dynamic property registry, and also here you need to annotate dynamic property source. These annotation came from the this specific test containers. Okay, so you no need to remember this annotation name, but whenever you are using the test container, you need to play with these annotation. Fine. Now registry dot add key name is spring.kafka.bootstrap server. I just need to copy the same name what I have defined here. So this is right. So you can define spring.kafka, then bootstrap servers. And what is the bootstrap server you want to specify? I don't know exactly the bootstrap server name, because this particular container will get the server for me. Every time you will run, you will get different server. Okay, so what we can do, we can tell here, hey, get it from the Kafka container itself. This is how we can specify. Fine. So we are done with the infrastructure setup. Now let's start writing our actual test case. So let's go to the project. We are going to write the test case for this guy. Okay, this Kafka message publisher, we want to send the custom object which is customer, this particular method. So let me copy this method name, then I will simply write the test method public void test. Fine. So to call this specific method from the Kafka message publisher, first I need to inject this. So just go here and I just need to auto add that private, then just do the auto add. That's it. Now I just need to call publisher dot send events to the topic. There are two methods we have defined in that publisher. One will send the string message, one will send the custom object, where we have just defined the customer as a DTO and we are sending it. So I am using the second method, I mean wherever I am sending the custom object. So I will create a new customer, what all field I need to pass, ID, name, email and contact number. So let's say ID is something, some random number, name let's say test user, email I guess, email is test@gmail.com, then what else, contact number, some random number. Okay, next just annotate this @test. Make sure to import the test from Jupyter, not from the JUnit. Once you have written this sent event to the topic will publish the message to the topic, and after that I want to pause for some time interval. So that is the reason we have used this utility class. So let me add the import statement. This should be import from org dot this particular class. Okay, and I want to wait, the pool interval is 3 seconds and minimum I want to wait for 10 seconds. And next to that, if you have any assert statement, you can add it inside this particular block. So just import this. So we are specifying the pool interval of 3 seconds, and at most, I mean the minimum amount I want to wait for 10 seconds once this particular message will push to the topic. So after that, if you have any assert statement, you can write it here. Since my method is void, I don't have any assert statement, I cannot write anything here. Even you can give a try by persisting that particular customer object to the DB, and you can just write the assert statement here by fetching it from the DB. So this is the simple example guys. Okay, nothing to worry. Now I believe all good. Let's run our code. So let me run the test case. Okay, it seems there is error. This particular method must be static. Okay, let's change it to the static. So if you'll make this static, better let's change this particular field also static. Now looks good. Let me run this. We'll find out some error, then I'll tell you how we can resolve that. So if you observe here, when the particular test will execute, first it will get that particular Kafka image. Can you see here? Starting to pull the image. What is the version? Latest. Now it will take few seconds to pull that Docker images. So you can see here, it successfully pulled the image of this specific version, I mean the latest version. Then it's trying to start that particular container. This is what, right? Now to verify whether it pulled the specific Docker image or not, what you can do, go to the terminal, just type Docker images. If you observe here, can you see here cp Kafka and the tag is latest. Now if you want to verify whether that is the container itself is running or not, just run docker ps. You can see here, right, the Kafka container is running here. Let me zoom this for you. The container is running here and this is the Docker image it pulled Kafka. Fine. So go back here. Let's see what is the result. So if you observe here, it's giving us the error because this particular test case will look into your application.yml file which you have defined in your source folder, I mean in the main folder, not in the test folder. There you have specified the bootstrap server as a 9092 localhost, but our bootstrap server is running dynamically. Fine. So for that reason, you need to override this application.yml in your test folder. So just create a directory, resource, just paste this and remove the bootstrap server so that it will pick from the container and will run it dynamic bootstrap. I mean the bootstrap server will be dynamic here. So this is not required for test. You can remove this. Fine. Now go to the test class and run it again. Now second time when I am running it, it won't pull the image again because it is already pulled that specific image at first time. Fine. So let's wait it to complete. See, directly pull the image here and it's starting the container. Can you see here? We got the message here. Sent message. This is what the object we are sending, right? With offset 0. Now if you go and check in the publisher class, after successfully send the messages, we are just printing this statement system.out.println sent message. This is what, right? If there is a exception, then it will print this particular statement. Since in our case we are able to successfully send the messages, we are able to get the first statement that sent message to the particular message and to which offset. That is what we can see here, right? If we'll go here to the test case, get the result, go to this specific test case. Now if you'll scroll down, you can see the log messages here, right? This is what we have written for producer. Now since I am a producer, I might have 100 of consumers, right? So now consumers, people need to write their own test case for consumer class. Okay, so let's start begin writing the test case for consumer. We are good with the producer. Now if you observe in the code, I have not worried more about the infrastructure. I have just defined these two lines. Everything will be taken care by this Kafka container itself. What I focused? I only focused on writing my functionality test, whether this particular method where I am exactly publishing the event is working or not. Okay. Now let's start writing the test case for consumer application. So I need this information. So first of all, first let me copy all the dependency what I have added here, because same dependency we need to add in our consumer as well. Copy this, go to the consumer application, go to the pom.xml, then just scroll down and paste it here, just update it. Fine. Now go to the test case here. This is the test case. Now let me copy all the field from the producer. I mean we are going to reuse the same annotation and Kafka container, so I will just copy paste. Just go to the consumer, paste it here, go to the producer, get the container and dynamic property source, copy this, then paste it here. I mean, whoever have the consumer for your application, they need to test their application that whether they are able to successfully face the events from that specific topic or not. Okay, so that is the reason they need to write the test case. So for that, how they can validate that whether the message is coming to the topic or not? So forcefully you need to send some event or messages to the topic. Then in consumer itself you need to write the logic to the, or you need to validate that whether it is consuming or not. Okay, that is simple statement, guys. So let me write the test case. Public, first let me go to the listener class, right? This is the class where my consumer is written here. I mean, this is the place I am consuming the event from this specific topic. So that is the reason we have defined the @Kafka listener. So I'll just take the method name, go to the test class, public void test. So to validate whether this particular method is being consumed or not, so what I'll do, forcefully I need to send some message to this topic. So for that, what I need a Kafka template. So I just need to inject here Kafka template of type string as a key and value as a object. Just inject using auto add. So here what I will do, I will just send Kafka template dot send object to which topic, the same topic what you have defined here, because I only forcefully send some message to this topic to validate okay this consumer is working correctly. Just specify the topic and just define the customer object. So I will better copy the customer object from here itself, just paste it here, or I will just define above. Okay, then just pass this customer object to this Kafka template so that it will publish the message to this topic, and this particular listener need to execute and it will print this log statement. That is what we are expecting. Fine. So what I will do, go to the test. First I will do one thing, I will just add some log statement here, SL4J. Then I will just add log dot info, let's say test consume events method execution started, something like that. And also I will just add execution ended. So execution will be start, then we are building the customer object, and through Kafka template we are sending it to the this specific topic. Fine. Now once it will publish to this specific topic, this listener will read that messages and it will print the log statement. Once everything done, we are just printing that okay the execution is ended. And you can also annotate here @test and make sure to import it from the Jupyter. Okay, this is as much as simple. Fine. Now here also what I want to do, I want to enable the application.yml. I mean I just want to uncomment, I want to use this application.yml and I want to comment this config class. Again you can try in both the way, but let's go with the application.yml so that if any test configuration required, I can add directly the YML file here rather than define the config class. Now here also I need to define the resource folder, new directory, resources, and just add the application.yml file. Fine. So make sure you need to define the same group in your test case. So let's go here. I mean not in the test case, this particular Kafka template will publish the message to this topic. Now if you go and check in the listener, the topic name is correct and the group name need to be this. Okay, I mean it is same only, that is how I have configured in YML file. So go to the test case, all good. Now let me run this. So it started the container here, can you see here? Now it will start executing our test case. So this test is executed successfully. Now if you filter this, we have not received the, I mean the request is not goes to my consumer. Fine. If you will see here, not here, to go to the main one, you'll find some error, right? org kafka.common producer is closed forcefully. So for that, what you can do, you need to wait for some time. I mean, the way we have done in the producer, similarly you need to wait for some second, because it might take some time to establish the connection, right? Or it might take some time to connect to the container. So it's good to keep some buffer time interval for sleep. Fine. Now let's run it. Just run from here. Restarting the container now. So it started our application. Now can you see here? Let's wait it to complete. Yeah, within a second it will be complete. Now if you scroll down, the JT group partition assigned to this particular topic partition, I mean the partition count is 0, and this is the topic name and this is the group name. And can you see here the messages? Let me zoom this. Consumer consume the event. This is what the 263 test user, test at the email and contact number. This is the object we are publishing through the Kafka template, and we have defined the consumer who listened to that particular topic, and my consumer is able to consume it. So if you observe here, go to the consumer, the statement we have written is same, right? Consumer consume the event, then what is the event it is getting? We are just converting it to the string. The same statement we are able to see it. I mean, we are able to successfully consume the event from our test case and using the test containers. So if you observe here, again, I didn't take much headache to define my infrastructure. I just defined these two statements, and rest everything will be take care by this Kafka container itself. I mean the test container itself. Okay. So the another advantages here, in this particular approach, the Kafka Docker container can be kept alive, which can help with the test performance and results in a testing environment closer to the production one. So this particular tutorial will give you the fully context how you can write the integration test for Kafka using the test containers. Whenever you will try to apply this specific use case to your real life situation, you can take it further by adding more test cases. You could also start refactoring your app or adding new features more reliable with the test that you have written. Okay. As you know, Apache Kafka run in a distributed manner across multiple containers or machines. It is also crucial to address the errors and recover the data in the event of failure. Sometimes what happens when a producer sends a messages and we process that message from the Kafka topic, error can occur. For instance, consumer services or related infrastructure such as database connections might be unavailable during that period. So in that case, there is a risk of losing any events sent or received due to the failure. So here, what we want to ensure, we don't lose any data and try to handle the failed messages. That's the challenging part, isn't it? But don't worry, in this tutorial, I will be explaining different way to handle errors in Kafka. Okay? Alright. Let me walk you through an use case. Consider a scenario where you are processing financial transaction. If a transaction fails to be processed due to some temporary issue, then how will you handle it? Because here we want to ensure reliable message processing. So what we'll do here, we'll instruct Kafka to retry the failed event. Now what Kafka will does here, he will simply reattempt process the messages multiple times as per your configuration. For example, if you set the retry count to 4, Kafka will make 3 retry attempts in a sequential order because it follows n-1 order. Okay, so if you specify 4 times to retry, Kafka will do 3 times. So that is how you need to decide what number you need to set for retry attempt. Next, if the process succeed within these retries, that's excellent. However, if the retry count is exceeded, then the message will be directed to the dead letter topic, okay, or the messages will be routed to the DLT. Now you might have a question, hey, what is DLT? DLT stands for dead letter topic, which is nothing but creating a new failure topic to store all the failed messages or all the failed events. If a consumer is not able to process messages even after retry, then those unprocessed messages will push to this particular dead letter topic. Okay. Now since you have failed records with you in a topic, subsequently you can monitor them to identify and investigate further. So this mechanism ensures that no data is lost. In the event of failure, we still retain the ability to handle and manage those failed messages, right? So this is the simple way to ensure that there is no data is lost and reliable message processing. So let's quickly see this in action. Let's go to our IntelliJ IDEA. Since already you discussed how to produce and consume messages using Kafka, so I have not wasting the time and I have created a project already. So if you check here, I have a publisher and I have a consumer. If you are not aware about how to play with the PubSub using Kafka, you can check out my playlist Kafka for beginners from my YouTube. I will also share the link in video description for your reference. Okay. Now let's jump into the code and try to understand what PubSub we are doing in this particular example. Let's go to the publisher. Publisher is the simple thing. What we are doing here, we are taking the user object as input and we are publishing it to the Kafka. Fine. Now if you open this particular user object, we have couple of fields called ID, first name, last name, email, gender and IP address. Now let's go to the consumer. What exact action we are doing in the consumer? If I'll open the consumer, we are simply taking that input, user input what we received from our topic. Then I'm just adding one validation here to simulate the error scenario. I have just added this restriction. Okay. So as part of the user, you can see there is a IP address. So when I will receive any user request or when I will consume any event specific to the user, I will validate that. Okay. If user is giving any of the IP specified in this particular list, then I will not allow that user to process further. Okay. So I have just added a simple if clause to check if the address, if the list contains the address, then throw some simple exception to just simulate the error scenario. Okay. Now what I'll do, let's simply run this particular use case, then we'll find out what is the problem with this particular implementation, then we'll go with the solution. So first I need to start the zookeeper, start it. Then let me simply start the Kafka server, just enter it. So here my zookeeper and Kafka server both are up and running. To validate that, what I will do, I'll go to this offset. Yeah, if I'll open this, I can able to make the connection. Okay, great. So this is the tool to visualize your Kafka payload from the producer end, and you can find the consumer related stuff as well. Okay, everything I have covered in my Kafka playlist. You can take a look to that particular videos. All good. Now let's start our application. So in config we have defined to create the topic. Can you see here? We have the topic name and here we are saying to create the topic with 3 partition and the topic name is defined in this application.properties file. Fine. So let's see the log. Can you see here? Java Techie group, that is what my consumer group partition assigned to. Since we have created topic with the 3 partition, you can see each and every partition here, right? 1, 2. So now just let's test our PubSub flow. So we have defined a controller class here. Here if you observe, we have an endpoint called publish new, where we are just giving a user object and it will call our publisher to publish the event to the topic. Okay, then our consumer will listen to that particular topic and will do the steps mentioned here. That's fine. Just go to the postman. I'll give some valid input first. So let me send the request. message published successfully. Now if you'll validate in your console, can you observe here? This is the log from producer. Okay, the messages is pushed to offset 0, and this is the log from the consumer. Can you see here? 235. Let's change the name to Basant, then last name something Uta, and give some random email ID. ID will be 2. Now let me send the request. The message published successfully. Again, if you check in your log, the second record with ID 2 from the producer log, and this is what the messages log from the consumer. Okay, it read from the offset 1 and also the offset 1 in the producer. This is the happy scenario, right? It is working as expected. Now let me clear this. Let me give some IP address which is specified here. Let me just change in the request body. Now if I'll send the request, let's see what will be the result. Message published successfully. Producer is successfully able to publish the message to the topic. Now the validation is there in our consumer, right? So what is the result here? Invalid IP address received. That is what we are expecting here, right? We are expecting to get the exception and we are getting it. Now what is the problem here? There is nothing, right? What is the problem here? The simple thing is that the record which we are not processed, if we will not take a look into it, there could be a chance for data lost, right? The record which we just received and what just we validate, that we need to take care of it. We need to reattempt, because see, here I am just added the if statement and throwing the exception. But let's assume from this piece of code it is connecting to the DV or it is connecting to the AWS S3. Okay, in that case, if that particular server is down and your request is not able to process, then that is the wrong practice, right? Because you completely lost that input what you received from your producer because of your AWS failure or because of your DV failure. Since this is the simple scenario, it's fine, we are just throwing the exception. Okay, but still we are losing that particular event or messages and we are not doing anything with that. So what we need to do, as per the presentation what we understand, we need to keep a retry. We need to tell to the Kafka, hey, can you please retry for 2 or 3 times? That is what the number I will tell to you. Once Kafka will do the retry, if within that time period, I mean let's say I have defined for 3, if after 3 times reattempt, if it is able to resolve the issue, then well and good. If not, if the retry count exceed, then it will simply push that failed event or failed messages to date later topic. Okay, that is what we just need to tell to the Kafka. So you need to tell to the Kafka about the retry, and if retry count exceed, then push the messages to the DLT so that we have a copy of our failed messages or failed events. So in future we can investigate it and we can reprocess it if required. Fine. So just go back to the code. Now here let me stop the server. So what you can do here, simply you can tell to the Kafka by defining one annotation, retriable topic. Okay, here you can tell to the Kafka how many attempts you want to perform. So you can define, I want to retry 4 times. So by default attempt count is 3. If you will not specify any attempt, Kafka will do 3 times attempt. Now since I have defined the 4, Kafka will do 4 times attempt. I mean to the same consumer will be keep executing for 4 times. Okay. So what will happen? Internally Kafka will create 3 topic just appending the suffix with retry. Okay, each topic will retry once. Since we have defined, there will be 3 times retries attempt. Okay, because as I mentioned, it will work on n minus 1 order. Okay, we'll test in a moment. Now what next? We are saying to the Kafka by defining this particular annotation, please enable retry mechanism for me and I want to perform 4 times retry. Okay. Now after 4 times retry, if the issue is not resolved, what do you want to perform? We want to simply push that messages to dead letter topic, right? So for that, what you can do, simply you can define a method public, then just copy the same header because the event is same, just define here. Now simply just add a log statement dot info and just define some messages. Just add some meaningful messages. Now what we have defined here, we are just saying what is the body and what is the topic from where we are listening and what is the offset count. Okay, so I can capture the entire body, but better to simplify the log statement, I'll just capture the name, then topic. So this looks good. Now what next? We need to annotate this method with DLT handler, dead letter topic and handler. This is what the annotation. If you open this annotation, this is the empty one. Fine. So using this annotation, we can able to enable DLT logic for failure message based on our Kafka topic. Okay. So using this annotation, this will listen all the failed messages. So looks good. Now let me start the application. So it started. If you observe the console log carefully, see here Java Techie group DLT. This is the topic name. Partition assigned this. And since as I already mentioned, for if you specify the retry count, for example, go here retry count. If you will specify 4, it will create internally 3 topic to do the reattempt. Okay, can you see here? Java Techie group retry 0. This is one topic. Kafka error handle retry 0, retry 1, retry 2. Can you see here? Now to just visualize it in a better way, what I'll do, I'll just refresh this Kafka Offset Explorer. Can you see here? This is our main topic or target topic where you want to push the messages and listen to it. Then it created DLT. Can you see here? I cannot maximize this. Let me try. No, I cannot do that. But you can see here, right? Then how many retry topic it created, guys? 0, 1 and 2. So the total count is 3 here, right? That's super, isn't it? Now let's do one thing. Let's quickly test this scenario. Let me restart. Okay, we already restarted it, right? Now I'll go to the Postman. First, let me clear this console. What I'll do, I'll just push the same messages, but I'll just give some valid IP so that I don't want to see any error first time. So just send the request. There is no error. We got the success result. This is the producer log. This is the consumer log. Now let me clear this. Now let's try with one failed scenario. I'll give the IP address which is already restricted in my consumer. Okay, let's change it to. Now let's observe carefully. Let me send the request. See here, it's doing the retry. Then it throw the exception. We'll verify in the log itself. Okay. See here, this is the first time it received. Then it did the 3 times retry. To verify, okay, Vasant, you are just showing the log. How can you get confirm that these 3 log statement being executed from the retry topic? Let me zoom this first. Then what we'll do? Just go here because we are already logging the topic name and offset name, right? What is the topic name here, guys? Kafka error handle retry 0. Kafka error handle retry 1. Kafka error handle retry 2. So it tried 3 times reattempt with 3 different topic. Now again if you want to check or if you want to validate again, go simply to your topic here. Just open the data. You can see here. Since in the log we found each topic retry topic received the messages from the offset, you can validate that directly in the topic itself. Can you see here? Fine. Now the retry is succeeded. After three times it retried, still we are not getting any result. It is failed. Can you see here? Invalid IP address, because since we are simulating the error scenario forcefully, you will get the error messages. But between that retry, if your DB connection or any AWS specific infra issue is being resolved, then you will get the response. I mean, that is the happy scenario. Since we are getting the error after 4 times retry or after 3 times retry, then where supposed to the message will go? To DLT topic, right? So if you observe here, it created a topic Kafka error handle DLT. Now let's validate message went to this particular topic or not. Just run it. Can you see here? This is the failed event went to the particular topic. But if you'll send the not failed event, I mean not failure scenario payload, let's say 239, I'll keep sending the request. Now if I'll validate in the offset explorer, no record, right? Nothing will come to DLT because only dead letter topic will listen the failed events. That is what we are saying in the code, and there will be nothing in the retry, only one. Good. So it's working as expected, right? Now there is also, you can play with this retriable topic annotation. Now continuously our retry is happening, right? I mean, there is no gap. But if you want to set the attempt in every or in some time interval, you can do that. You can simply define backoff. Okay, then you can specify the what is the delay you are expecting and what is the multiplier. All these stops you can define. Then what is the max delay, you can define those value. This is the number, not integer. For example, I will just define 3000, I mean 3 second, then multiplier 1.5, and max delay could be 15,000, max 15 second. Now this is how you can define the when you want to do the retry attempt, not if you don't want to do it immediately. If you want to specify your own time interval, you can define this. Now also you can tell to this retriable topic for what kind of exception you want to perform this retry. Now for runtime exception, if you don't want to perform this retry, what you can do? Simply you can define here, please exclude the retry for this exception. What is the exception name? Null pointer dot class, or I don't want for this runtime exception, right? Runtime exception dot class. You can also control for what exception you don't want to do the retry. Okay, you can exclude them. For this kind of exception, there will be no retry. So it is up to you, based on your need, you can configure it. Fine. So this is how you can override the behavior of this retriable topic. Now let's do one thing. Let's try to produce bulk record and we'll see this particular behavior. Okay, let's go to the publisher. I'll go to the controller class. So I have a CSV file, list of user. Okay, I mean I guess 100 is there. There is total 100 user object. I want to load this CSV file and will convert this particular to list of object, this particular user in CSV to list of user object. Then we'll push one by one to our publisher. Okay, so it's a simple step. I have just written one util class to load the CSV file and convert it to the list of user object. Then what I'll do, I'll go to the controller class. I'll call this method to load the CSV data and convert it to the list of user. Now simply what I'll do, I'll just use users.forEach user object, then simply call this. Now it will trigger 100 event. Out of 100 event in my consumer, I have restricted 4 user IP address. Okay, it means out of 100 row, 100 user object, 4 user will be discarded and will go to the DLT. Okay, when I say DLT, it is dead letter topic. Okay, now if you observe, we have only one record in our Kafka error handle DLT. If I'll run it again, only one record. Now once I will execute this, there should be 4 more record which need to add in this particular topic. Okay, so what we'll do, because see the simple thing guys, whatever the IP I have specified here, see I have taken it from this particular CSV. Okay, all the 4 are there, I took from here only. Now let's do one thing, let's rerun our app. Okay, let me stop this because we need to, it's fine, we can run it. I mean, what I supposed to do in the controller class, now I am not giving the input. Even though I am giving that input, it does not make any sense. Anyway, at the end, it will iterate the CSV and will push those messages. What I am giving here is not being pushed. So I supposed to define a new endpoint saying get or something like that. But it's fine. We can play with the same because whatever the value will give will not be used. So fine. Let me clear this. Just go to the postman. This you can give any value. Okay. This is not being used. Send the request. Message published successfully. Now if you'll go and check your console, can you see here? These are the messages from producer. Okay, and if you'll scroll down, these are the messages, right? 1 2 3 4 5. Is there any error? Let's see. Invalid IP address received. It will do the retry. Can you see here? DLT also received some messages, and if you observe here, it did retry. I mean, since there are 100 record, it's not easy to check the log to find out the retry count and its validation. Now to validate in a simple way, see there are lot of error, right? DLT received this. Just verify one thing, how many DLT received messages you have there in your console? 4, right? Because we have only 4 restricted IP address out of 100. Whatever the file we have in the CSV, we have here. Okay, let me show you here. Only 4 user IP address are not correct. So rest others should process the result. Now to validate that, go and check in your Offset Explorer. Just run this. Can you see here? 1 2 3 4 5. This is the first record which we added before executing this bulk record. Then 1 2 3 4 with the same IP address. Take anyone's IP and just check in your CSV. Okay, also check in your consumer whether you have restricted for this user or not. Can you see here? Fine. So whenever you are performing the bulk upload kind of scenario using Kafka, you can do this kind of validation using this retry template. And for failed event, rather than losing those data, better to keep it in some different topic, and you no need to create that topic manually. That will be take care by Kafka by defining the simple annotation DLT handler that is called dead letter topic. Okay, and everything will be take care by Kafka, so that you have the failed messages with you. You can play with them or you can investigate with them in future whenever it needed to process those details. So this is how you can handle the error in Kafka using this DLT and retry mechanism. Okay. In this tutorial, we'll learn about how to use Avro schema to produce and consume messages using Spring Boot. Additionally, we'll explore the concept of schema registry, what does it mean, and what benefits does it provide. Okay, alright. Let's assume I have a stable Kafka producer and consumer application where I am sending employee details to a Kafka topic, and the consumer read it from the Kafka topic and perform some further operation. This is a happy scenario of pub sub mechanism, right? But what if I change the producer data? If I change the record to this new format where I am adding a new field called middle name, and I am renaming one existing field called email ID, and I am removing one field called DOB. Now the problem starts from here. Will my consumer work with these new records? The answer is no, because the consumer is not aware of data changes, and that's a big problem, isn't it? If there is any changes in my data, it will directly impact all my consumer, which is not acceptable in real-time implementation. So how to overcome this? The simple solution is to write a new producer and consumer application so that new data will be produced and consumed by the new instance without impacting the existing flow. However, that requires too much work, and that is not a feasible solution. Then again, how to solve this problem, or how to handle data changes or schema evaluation? So that's where Confluent Kafka introduced the concept of Avro schema, and to store those schema, it has a component called schema registry. Okay, now let's go one step ahead and understand what this Avro schema is, how to use it, and how to handle schema evaluation. Then further, we'll understand how it works internally. So when I am saying Avro schema, it's nothing but a contract between your producer and consumer. It represents the data that you are going to serialize while producing and deserialize while consuming. Now if I try to represent the equivalent Avro schema of our record, it will look something like this. Now if you observe carefully, we are defining an Avro schema saying that, okay, these are my fields which the producer will send and the consumer will consume. In case the producer is not sending any of the field or adding any of the new field, then there should not be any impact on the consumer side. Also, if any changes are made to the schema, it will be considered as a new version. Okay, that is what called schema evolution. I have the contract or schema with me. Now, how can I use it? That's pretty simple. Once you prepare the schema, you need to generate the corresponding object out from the schema. So you need to define all the field, whether it is optional or mandatory, in your schema file. Then you need to generate the Avro object. To convert Avro schema to Avro object, you have multiple options. You can directly use the Avro tool, or you can use Maven or Gradle plugins to generate the object for you. Once you have generated the Avro class, then going forward, you can use this employee.java as a data object which you can produce and consume. But while producing this object, we need a serializer from the producer end who will serialize the Avro encoded message and send them back to the Kafka topic. So we can use Kafka Avro serializer. Similarly, we need a deserializer from the consumer end who will deserialize Avro encoded message and convert them back to the object. So we can use Kafka Avro deserializer. That's straightforward, right? Here Kafka Avro serializer and deserializer takes all the responsibility of converting your encoded Avro message to the corresponding object and perform the serialize and deserialize operation. That's interesting. But where is the validation part? The encoded Avro message that my producer is sending, whether it matches to the schema I have defined or not, where are we validating it? Or How does my deserializer deserialize the raw bytes to an object without knowing the schema? That's the major part we need to deal with to avoid failure on schema evaluation, right? So that's where schema registry comes into the picture. What schema registry does, it store your schema. So when Avro serializer serialize the record, it first validate and store the schema into the registry. Then when Avro deserialize, it first takes the schema from the registry, validate it with the messages, and then deserialize it back to an object. The primary purpose of schema registry is to provide a way to store, retrieve, and evolve the schema in a consistent manner. So in the future, if I am making any changes to my existing schema, it will create a new version and store it into the schema registry. Since schema registry has the flexibility to support both backward and forward compatibility, if any upgrade happens to the schema, it will support the old schema as well as the new schema. That is how it handles schema evolution. Hope this makes sense to you. No worries, we'll do a hands-on example with all the theories we understand. Okay, so without any further delay, let's get started. So let's create a new project to demonstrate this schema registry. I'll create a new project, then define all the required field, click next, then just define all required dependency. I'll add web dependency, then I need Lombok dependency, then I need Kafka dependency. Click next. Now once it imported, just go to the pom.xml and we'll validate that we have added the web dependency and we added Spring Kafka and we added the Lombok dependency, right? And anything else? No. But why there is error? Okay, it is saying starter parent 3.2.2 not found. Okay, let's downgrade it to the 3.2.1. Let me update the project. Now let me clear this. Next, we need to set up our Kafka environment. So we want to use the Confluent Kafka. You can download the binary distribution and you can start the Zookeeper, Kafka server, service registry, everything from the command prompt. But I would prefer here to use the Docker compose file. I will just define all the container I need so that if I will do the Docker compose of, it will start all the services for me. Okay, so I will just define the Docker compose file in this root directory. Then I can define all the services I need. So if you observe here, let me zoom this for you. I need the Zookeeper, then I need the broker, which is nothing the Kafka server, and then I need the Kafka tools. So this Kafka tools is available for administrative tasks, so you can ignore it, this is optional. And I need the schema registry. So you understand what is the role of schema registry, right? So we need this schema registry component who will store the schema and validate with the encoded Avro message. And we need the control center. So this is just a UI platform to monitor your Kafka activity. Okay, so this control center depends on Zookeeper, broker and schema registry. It collects all the information from these three components and mapped into the UI. Okay, and it will run on the port 9021 and these are the environment variable of each services what I have defined. Okay, no worries, I will share this GitHub code in the video description. You guys can refer to the same file. So now to start these services, we need to start our Docker first, right? So I will just open my Docker desktop in my local machine, and once it will be start, then I can just trigger Docker compose up so that all the services what I have defined in this compose file will be up and running for me, and I can do the further step with this Confluent Kafka. So let's wait it to start. So Docker is up and running now. Now what I'll do, I'll go to the terminal. So simply I will trigger Docker compose -d. Okay, now if you observe, it is just starting my all the services. So if you observe, it started the zookeeper, Kafka tools, then Kafka server, schema registry, and control center. So to verify that whether it started or not, what I'll do, I will just check the port of my control center, that is 9021. I'll go to the browser and I'll trigger 9021. It's loading, right? So it means it started. So we are good here. Now what you need to do, we'll follow the same step what we have discussed here. First we'll create the schema, then using the Maven plugin we'll generate the corresponding Avro class, then we'll define the producer and consumer, and we have defined the serializer and deserializer and schema registry. Okay, so the first step, let's create the schema. So just go back to ID. In the resource I will create a folder called Avro, then I need to define the schema here. Okay, so let me create a file called employee.avsc. So this .avsc is the extension of Avro schema. Just create it. Then here you need to define what is the package where you want to keep your generated class. So just define the package name. I'll define com.javatechie.dto. Let me zoom this for you. Fine. Then next you need to define what is the type. So you want to define the Avro record, right? So I'll define the type as a record. Now what is the class name you want to keep? So from the schema, the class what it will generate, what name you want to give. Okay, so the name I'll define employee. Next to that you need to define all the field which you want to produce and consume. So what you can do, you can define fields that need to be one array, and you can define all the field you need. So if you will verify the field we have defined, ID, first name, last name, email, and DOB. So let's go to the ID. I'll define the field name is, the first field name is ID, of type it will be string. Okay, simple, right? Now I will define another field. Let me copy the same. The field name is first name. Okay, and okay, there is a spelling mistake. RST name, of type string. Then the next, last name, type is string. Then what else? First name, last name, email, and date of birth, right? So define the email here, of type string. Then DOB, of type string. And also let me add one additional field called age, of type int. Okay, you can define any data type here, string, int, double, as per your requirement. Okay, also you want to keep, let's say I just want this email to be optional. So what I can do, I can define here default value should be, you can define null or you can define empty. Okay, so this is what the schema I have defined. This particular field my producer will publish and my consumer will consume it. That's fine. Now next, if you observe the flow, we have the Avro schema with us. Next we need to generate the Avro object by using the Maven plugin. Okay, so let's go to the ID and we'll add all the required dependency and plugin. So just go to the pom.xml and then I will add all the required dependency. So if you observe here, we need the Avro serializer. Let me zoom this for you. And then we need the schema registry and we need this Avro object. Okay, then we just need to add the plugin. Just add it here, just update it. So we are getting the error, what it is saying, cannot resolve this dependency. Okay, so it is looking from the Maven central repo to load these two dependency, schema registry and Avro serializer, but in Maven it is not available. Okay, so what I'll do, I will tell in the POM to load it from the Confluent repository. Okay, Now if I'll just update it, there should not be any error. Okay, there is no error. Now if you will go to the plugin section, if you observe here in the configuration, I am telling here this is what my source directory, where you can find my schema, and this is what the output directory where I want you to generate the object for me. Okay, and the version of Avro Maven plugin we are using 1.8.2. So that's fine. Now let's run the Maven goal to generate the object for us. Just go to the Maven, run the install. So here simply we are telling to take the Avro schema and generate the Avro object for us. So the build is succeed. Now to validate that, what we can do, go to the main Java. Now you can see here, right, there is a package called DTO, and this is what the package name we have defined in our schema. Can you see here? The namespace or the package we want to generate the Avro object is this. Now if I'll open this, I can see the Avro class. Now if I'll open the employee.class, let me zoom this for you. This class extends from specific record base, specific record, and this is what the schema what we have defined. Fine. Now if you will scroll down, you will find all the field. Can you see here? ID, first name, last name, email, and date of birth and age. Also you can find the constructor here. This is what the default constructor, and you can find the getter and setter method as well. I mean, this is just a class generated by the Avro. Now we can use this particular employee as a data object to perform the producer. I mean, we can publish this particular object and we can consume this particular object. So to do that, let's create one producer and consumer application. Okay, so what I'll do, I'll create a separate package here itself, and I'll create another for consumer. So I'll just define package. Fine. So let's create one producer and consumer class. But before that, let's verify the flow what we have discussed. We have the schema with us, and we created the employee.java class, which is nothing the Avro record. Now we'll create the producer and consumer. Then we'll define the Avro serializer and deserializer, and we'll validate the schema registry. I mean, we also need to give the configuration of schema registry to store all the schema. Okay, so we are in the third step to create the producer and consumer. So just go to the idea, and then I'll just create a class here. Then just annotate here @service. Then I just need to define the Kafka template, right? Private Kafka template of type, you can define string, and of object employee, right? That is what our object, Avro object. So I can define template, just do the auto add. Then just define the method public void send, something like that. Okay, define the object what you want to send, employee. This employee is not our object, right? It's the Avro object. I mean, you can consider it as a Avro record. So to do that, I will just do Kafka template dot send. What is the topic name? We have not defined the topic, and we want this topic to be auto create. So for that, what I'll do, I'll just create a config class, or I'll just create a package called config. Then I'll define class name Kafka config. So I just need to annotate this with @configuration. Then I'll just create the topic. I just need to create the bean of topic. Public new topic. This is the class name. Okay. Now create topic. I'll just define the method name. Then return. See, if you observe here, you just need to define the name of your topic, number of partition, and replication factor. So I'll just define the name, let's say Java Techie -Avro, and number of partition I want 3, and replication factor I want 1. So I can define 1, just need to typecast to sort. Just annotate this @bean. Let me maximize this. Yeah, define @bean. Now I don't want to hardcode this topic name here. So what I want to do, I have the application.properties file, or I will just create a file called YML file, and here I can define my topic name. Okay, so I'll define topic name equal to this. So I want to make it generic, so I have defined the topic name in my configuration, I mean the YML configuration, and that I will load in my config. So you know how to load the value from the properties file, right? I'll just define private string topic name. I just need to annotate here @value, and I just need to get that value from my YML file. So just define the dollar and give the key. What is the key name? Topic dot name. That's it, right? So I no need to hardcode here. I can use the topic name. Same topic name I can use while producing the messages. So here also I can use the topic from the properties file. So let me copy this syntax. I need this topic to publish the messages, and what data you want to publish? Employee. Fine. Next I'll just capture the return statement, so that we can just add the log statement, what data we are sending, what is the offset count, and everything. Okay, so this will give you the future object. Can you see here? This will return the completable future. Now I'll take that future object and I'll just get the result. Okay, so this will be employee. Nothing, I'm just checking if there is no exception. Print that okay, message has been sent to this is what the message we have sent, and this is what the offset count. But if there is a error, just print that unable to send the messages. Okay, that is the simple things we have done here. Now let me define the consumer. Let me copy the name. I'll go to the consumer package, create a new class. Fine, consumer is the simple one. What you need to do, just define the annotation first to make it a component. Define service, then you just need to write a method to listen to the topic. So just define public void read messages. Which type of messages it will read? Let's say define consumer record of type key as a string, value as a employee. Fine. Now I just need to tell to this consumer from where he need to read that messages. Okay, so just annotate Kafka listener and just define what is the topics. Just tell that okay, read it from the topic what I have defined in my properties file. That is the reason I move it to the properties file to make it generic. Rather than hard code in each and every place, I have just defined it in a single place. Okay, so topic dot name. So we are telling to this particular listener to read the messages from topic what I have defined, and what messages it will read of type employee. So what we can do, just add the log statement, okay, to verify that. SL4J, this we added from the Lombok. Now here I will simply first get the key. Are we sending any key? No, we are not sending any key, right? But still let's capture it, or we can pass it from the producer itself. Consumer record dot get key. What is the value we are sending? Consumer record dot value. So now we can just add a log statement. Just add the log statement. Avro message received for the key is this and value is employee, right? Okay, I have done the mistake. This value should be of type employee. That is what we have defined. So this need to be employee, because this is what the value we are getting, right? Key is a string. It can be serialized and deserialized by a string serializer or deserializer, but value is something object which is Avro object, and it needs to be serialized and deserialized by the Avro serializer and deserializer. So that we are going to define in a moment. So this is what we are getting. Fine, we have defined the producer and we have defined the consumer. Now let me define a controller so that I can trigger an event. So just create another class. Just define the package called controller. Just annotate here @rest controller. Then you can define you need to inject the producer. Then just define an endpoint to trigger the event to the Kafka topic. Okay, so I'll just define public string what type of messages we want to send employee. Then you can simply define here producer dot send what is that employee object, and I can return some dummy string message, and this need to be annotated @request body, and I need to annotate here @post mapping since I have the request body, and I'll define the endpoint events. And this particular application I want to run it in a different port, so I'll just define server dot port, let's say 9292, or let's take some different number. Okay, 8181, something like that. We are good now. Okay, so if you cross verify the flow, we have created the producer and consumer, and now the next step we need to define what is the serializer of my value, what is the deserializer of my value, and then where is my bootstrap server is up and running. Everything I need to define as a configuration. So what I can do, I will prefer to define in a application.yml file. You can also create a Java based config class, but I can define here in the YML file. That is the easy approach. Okay, because I don't want more customization, so I just need to use the producer and consumer config in the YML file. But if you need more configuration, customization of more configuration, you need to go with the Java based config approach. So I need to define here Spring Kafka producer first. Okay, in the producer first I need to define where is my bootstrap server, where is my Kafka is running. So where exactly it is running, you can define localhost 9092, right? That is what usually we define, localhost 9092. So if you observe your docker compose file, go to the docker compose file, the bootstrap server, if you'll scroll, yeah, can you see here, this is what your Kafka server, right, broker, and it is running on port 9092. That is what we are just defining here. So just go to the YAML file 9092, but we are not running it in our local, we are running it in a docker. So you need to give the default IP. So my default IP is 127.0.0.1 colon 9092. Fine. Now I can define the serializer, key serializer. Okay, so the key serializer is the plain string. I can use this string serializer, which is the default given by the Kafka itself. Okay, but if I'll define the value serializer, I cannot define the JSON deserializer here. I need to define the Avro Kafka Avro serializer. Okay, coming from the Confluent. That is what we have discussed in our flow, right? We need the Kafka Avro serializer to serialize my value to the topic. So we need to define that. So just define the class io.confluent.kafka serializers. Can you see the class name? Kafka Avro serializer. We are using this Avro serializer to take the encoded Avro messages and send it to the Kafka topic. So we are good. Now also we need to define the schema registry, right? So I will just define properties schema registry. Now where is your schema registry is up and running. If you go to your docker compose file, the registry is running on port 8081, right? So I need to define that. HTTP, then your IP and your port, that is 8081, and my IP is this one. Fine, this is where my schema registry is up and running. We are good. Now let's define the consumer configuration. Now consumer also you need to define the bootstrap server. This is where the bootstrap server. Let me copy this. Next, here also if you observe in the consumer part, we need to define deserializer properties, right? So I can define here key deserializer is the same, that is my string. So I am using the default Kafka string deserializer, but value deserializer should be from IO confluent Kafka Avro deserializer. Just define that class. We are good here. Now next you need to define auto offset reset. You can define it as earliest or latest, it is up to you. Next, in consumer also you need to tell to that consumer, okay, where is your schema registry up and running. If you observe the flow, both Avro serializer and Avro deserializer is connecting to the schema registry, right? So you need to give information about schema registry to both your consumer and producer. So we have given here in the producer. Now same let's give in the consumer. So it need to be inside the code. So that's fine. I'll just define properties. Next, just define one additional field, that is to tell to the consumer to read the Avro messages. Okay. So there is something called specific, okay, and Avro reader equal to true. That's it. Okay. So the main thing we need to define serializer and deserializer. That is what we want to define, and also you just need to define about your schema registry. So these are the three components we are missing: serializer, deserializer, and schema registry, and these three we just configured in this YML file. Okay, but one thing I observed here, producer also need this property bootstrap hyphen server, and consumer also need this property. So better let's not define in both the place. I can define it in a global level in Kafka itself. Bootstrap server, this looks good. So Kafka having the bootstrap server for both producer and consumer, and in producer we have defined the focus on this value serializer. Okay, we have defined Kafka Avro serializer, and we are telling to the serializer about where is my schema registry up and running, so that he can add the schema to this registry. And we have the deserializer, and we are telling the again about the schema registry, and we are telling that here, okay, read the Avro messages. Fine. So we are good here. Now let me close everything. Just go to the producer. I just want to add a key. Okay, while sending the event, I also want to add a key of type. Let me zoom this for you. Of type UUID. I want to send some random string. Okay, random UUID dot toString. So while publishing the messages, I am sending the key. Along with that, I am sending the Avro messages. And if I'll open the consumer, in consumer we are consuming both key and value. Key is nothing the string, value is nothing my Avro messages, and we have defined all the component we understand in this architecture. Fine. So I believe we are good. Let's start the application and we'll see how it works. So let's go to the main class. Just start the application. So we are getting some error here. What is the error? Okay, no group ID found in consumer config. So that is what the mistake we have done. We have not specified the group ID. So I will just add group ID as a some random value. Okay, Java Techie new. All good. Let's restart it now. So we are good now. If you observe in the console, the Java Techie new is nothing my consumer group assigned to this particular topic Java Techie-Avro with the 3 partition 0, 1 and 2. Can you see here? Let me clear this. Now I want to verify the same thing in the control center. Okay, just go to the browser. This is where the 9021 is my control center, right? Now this is where the cluster. If I'll open this, it should have our topic info. Can you see here? The topic name is there, Java Techie Avro with the 3 partition. If I'll open this and if I'll check the messages, you won't find any messages because we have not published anything. So there is nothing, it's still loading, no messages, right? So let me keep a duplicate page of this particular thing, because until you are open to this page you can see only those messages. So this is just a tool to monitor the event whether it is going through your producer and consumed or not, for the simple purpose. Now if I'll check the schema here, I don't have any schema mapped to this particular topic. So here when schema will be added, when it will be serialized, then only Kafka Avro serializer will push that particular schema to schema registry. That is what we understand in the theory, right? Let's verify it. So what I'll do, I'll go to the postman and what is the endpoint? Let's verify in the controller class. Go to the controller events and what is the port number? 8181, I believe 8181. Yeah. Go to the postman 8181 events and what is the request body? We have lot of field. Let me add those field. So these are the field we have defined in our schema. Okay, so we can only pass this field and then we'll play with the schema evaluation once we'll go through one happy scenario. Just format it. Before I send the request, let's check the status of schema registry, whether we'll verify whether schema is added to the schema registry or not. Okay, how can I validate that? So the schema registry is running on port 8081, right? First let me 8081, I want to get all the topic name. So topic is not created here, not sure why it's not showing in the schema registry. I believe after sending one object it will show, but okay, let me verify the latest schema. Okay, we cannot do that since the topic is not showing here. Let me refresh it, nothing, but topic is there, right? That's fine. Let me trigger the request. Can you see here we got the success result, message published. Now if you check in your console, send messages, this is from producer end, these are the information we are sending and it went to the offset 0, and this is from consumer end. Can you see here? This is what the received message and this is what the messages we send from the producer. Now to validate that, just go here. Can you see here in the messages we can see the message. This is what the messages we have sent just now, right? And if you now validate the schema, just check the schema, you can see the schema here. These are the field we have defined, right? ID, first name, last name, email with the default field, date of birth, age, and the Avro class name, package, everything. All the schema we have defined is imported here. Once the Avro serializer is serialized and send the event to the topic. Now let's verify the topic name. Yeah, can you see here the topic name is this. Now to validate the schema in the schema registry, what you can do, localhost 8081 subjects, then topic name. What is the topic name? Copy again, just replace the topic name. Can you see here? Let me zoom this for you. Subject is nothing the topic name, I mean the value as a suffix will be appended by the Kafka confluent, and version is 1, ID is 61. This is what the schema. We can see the schema in the schema registry. So we concluded that schema registry has the schema information, while Avro serializer serialize it added to the schema registry. And since we are able to receive the messages from the consumer end, Avro deserializer deserialize it. Okay, and which version of schema we have? The current version is 1 because there is no change. this is the fresh schema added to the schema registry. So this is the happy scenario we validate, right? We can able to produce the message and we can able to consume the message by taking the help of Kafka, Avro, Serializer and Deserializer, and also we validate the schema in schema registry, and we can able to visualize the messages and everything from the control center. That's fine, but our intention here to check the schema evaluation related things. So if I am doing any change on my producer data, whether it will impact to my consumer or not, that is what we want to verify, and that is why we are using this schema registry. So let's jump into the presentation and then we'll perform these schema changes. When I say schema changes, we just want to do some modification on our object which we want to produce and consume. So what we'll do, we'll remove the date of birth field and age field, and we'll rename this particular field email to email ID in our existing schema. So just go to the schema. So the schema is employee.absc. Here we want to remove the DOB and age, just remove it. And then I want to rename this email to email ID. So we have done two changes here. We have removed two field DOB and age, and we rename one of the existing field. Now let's see if I'll run the application, whether it will break my consumer or my consumer will work as it is without any impact. Okay, that is what we want to verify. But since we have done the changes on the schema, we need to regenerate the object, Avro object. Let me stop the application, then just execute the Maven goal, install. So the build is succeed. Now to validate whether those fields are excluded from our Avro object generated by the Avro plugin, we can go to the DTO and we can validate. Can you see here? Those fields are not part of the Avro object now. Now let's run the application and we'll trigger the endpoint to publish the event. Then we'll validate whether the consumer is working or it is giving any error or exception. Okay, so that is the reason we are using schema registry to manage the schema if I am doing any change on my produce object or Avro object. Okay, so let's wait it to complete. So it started. Now I'll go to the postman and I'll change the field. Actually we have removed these two fields, right? DOB and age, just remove it. Age and DOB is removed, and then this will be email ID. That is what the changes we have done. Cool. Now let's trigger the API. We got the response message published. Now if we'll go to the console, you can see here, right? ID, first name, last name and email ID. This is what the object we have produced from the producer, and this is what the serialized as part of the Kafka Avro serializer. And then if you observe here, this is what the message we have received in the consumer end, and in both the place producer and consumer we don't have those field. Now if you will go and check in the control center, if I'll go and schema, if I'll come back to the messages, so message might not be present here, so I can re-trigger it to validate that. So just send the request again. You can see the messages here, right? Those field is not part of the messages itself, nothing is there, right? Now if I'll go and check the schema, let me refresh this. I'll come back to schema again. Can you see here? Schema is also updated. ID, first name, last name, email ID. Now if you'll check the version history, there are two versions, the initial version and second version. In initial version we have the fields, right? DOB, age and email. But in the current version those fields are not there. So if you want to compare, you can click on this turn on version difference and you can see here these are the field has been removed. So you can see the red mark here and the value is renamed. You can see this. Okay, this is what the difference. Now if you want to validate the same thing in the schema registry, instead of this control center UI, just trigger this request again. Can you see here? The version is 2 and the schema is this. This is what the latest schema. Okay, I have done the changes on the schema, but still my consumer is not breaking. I am able to consume the messages even the field has been removed from the payload or Avro messages itself. So that is the main purpose of using this schema registry. If you observe here, it maintains the schema history. Okay, so it maintains the different version of your schema. Since it has the backward compatibility, it cross validate your Avro messages with all the schema present in the schema registry. Now let's do another changes and we'll validate whether the schema evaluation is working with this particular implementation or not. So what changes? When I say changes, let's add one more field. Okay, so go to the project, go to the schema. I want to add some field. So as per the discussion, we need to add some different field like middle name or something like that. Okay, so let me add that field. First name, last name. Let me copy the same, and I want to add middle name. Now since I have done the changes on the schema, I need to rebuild the project. Let me stop the Kafka. I just need to run the Maven install again. So you can see here build is succeed. Now if I'll go to my DTO class and if I'll open it, let me see whether the field is added or not. Yeah, can you see here? The middle name is added here. Now let's do one thing. Let's start the server and we'll add this middle name as part of our payload. Just check. Okay, it's still running. Let's wait it to complete. Yeah, so it is started now. Let me clear this. And now what I'll do, I will trigger the request. Okay, again we have done the schema changes. We have added the new field which is not present in my both the schema. I mean schema version 1 and 2 does not have the information about this new field. Now let's see whether it is working or we are getting any error. Then we'll try to find out the solution of it. Send the request. We are getting 500 internal server error. Now if you go and check in your console, the error itself self-explanatory. Invalid configuration exception. Let me zoom this for you. Schema being registered is incompatible with an earlier schema, error code 409. It means whatever the schema I have with me and the value you are giving now is not compatible. Then how can I make my schema as a compatible to avoid this 409 error? So what you can do, if you are adding any new field, then initially mark it as a default. Okay, then what you can do, since you have done the changes, just build it again, then we'll start the server and validate. So build is succeed. Now let me restart the server. So it started. Now go to the postman and send the request again. The message has been published. Now if you'll go and check in the messages, can you see the message here with the new field middle name? Can you see here? We got the response. Now if you'll validate the schema again, version history, there are total 3 versions. In first version, it was the happy scenario. We have all the field. In second version, we have removed the DOB and age and we rename email ID. Then let's see what is there in the third version. Third version, we have just added this field middle name. Now if you will compare it, you can see this field is newly added. Okay, and we are not getting any error. So this is how schema registry maintains the schema and validate against the Avro messages what you are producing and what you are deserializing or consuming. And this way you can avoid the failure in the schema evaluation which will not break your entire system. Okay, so this is what the straightforward approach we have demonstrated about the schema evaluation using schema registry and Avro producer and consumer example. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.